There is not even one marble in the 7th jar. So we have to write 0 in the ones box. Now, we have 6 in the tens box, which means 60. And 0 in the ones box, which means there is not even one marble there. So there are 60 marbles in total. Understood, children? A group of 10 objects is called one group of tens. Similarly, whatever is the number of groups you have to write that number in the tens box. And when there is not even one object in the group, you have to write 0 in the ones box.
We understood.
Now look, in this empty 7 jar, I am putting some marbles in it. Now tell me, Lily, how many marbles are there in total?
Here in the first 6 jars, there are groups of 10 marbles each. That means there are 6 groups of 10 marbles each. That is why in the tens box, we have to write 6.
Well done, Lily.
Now in the 7th jar, we have put 1, 2, 3, 4, 5, 6, 7 and 8 marbles. So in the ones box, we have to write 8.
Well done, Billy. But my question was, how many marbles are there in total?
Here in the tens box, there is 6, which means 60 marbles. And in the ones box, there is 8. That means there are 8 marbles. That is why there are 60 and 8, 68 marbles in total.
Yes, well done. Now look, children, I will teach you how to expand 68 into 2 parts. 68 has 6 tens and 8 ones. So 6 tens means we have to write 60 and 8 ones means we have to write 8 here. Come on, Billy. Now try to expand and tell the numbers written here on the board.
28 has 2 tens and 8 ones. So 28's expansion is 20 and 8.
Very good, children. Now see you in the next class. Children, in this video, you learn to expand 2-digit numbers and write it in boxes of tens and ones. In the next video, through examples, we will learn how to expand 2-digit numbers and understand it well. Children, in this video, we will learn to form 2-digit numbers using bundles through some interesting examples. Children, in the last class you had learnt to form numbers in the groups of tens.
Yes, ma'am.
Let us see through some examples how much you remember. Look, there is an abacus given here. You have to look at it and form a number. Lily, you tell us.
In the abacus given here, in the tens box, there are 1, 2, 3, 4, 5, 6 and 7 beads. So in the tens box, we have to write 7.
Very good.
Now, in the ones box in the abacus, there are 1, 2 and 3 beads. So, in the ones box, we have to write 3.
Well done.
Now here, in the tens box, 7 tens means 70 and in the ones box, 3 ones means 3. So, adding 70 and 3 makes it number 73.
Absolutely correct. Now how will you expand 73 into 2 parts?
73 means 7 tens and 3 ones, meaning its 2 parts will be 70 and 3.
Well done. Now, let us look at the second example. Look, Billy, here we have to count one small block as 1. Now tell me, what number do all these blocks represent?
Here in the first big block, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 small blocks. Means there is 1 tens.
Well done, Billy.
Similarly, there are 1, 2, 3, 4, 5 and 6 groups of 10 blocks each. So, 6 tens make 60. Now there are 2 small blocks, which means there are 2 ones.
Very good.
Now adding 2 to 60, here we have 60 and 2, giving us number 62.
Now, how will you expand 62 into 2 parts?
62 means 6 tens and 2 ones. That means the 2 parts will be 60 and 2.
Absolutely right, Billy.
Children, you saw Lily Billy form
2-digit numbers with the help of abacus and blocks. In the next video, we will understand some interesting facts about forming 2-digit numbers
with the help of bundles of tens.
Children, today we will learn interesting facts about forming 2-digit numbers using bundles, place value. Children, can you make bundles of tens out of these 43 ice cream sticks?
But ma'am, these are 43 ice cream sticks. How can we make bundles of tens out of these?
Let me explain. There are 43 ice cream sticks. First of all,
make one bundle of tens out of them.
1, 2, 3, 4, 5, 6, 7, 8, 9 and 10.
Here is one bundle of tens. Come on, Billy. Now make the second bundle of tens from the remaining sticks. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. This is the second bundle of tens.
Now form the remaining bundles 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10.
Look, we made a third bundle of tens also. Lily, now you say whether you can make another bundle of tens from the remaining sticks or not. Yes, ma'am. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Ma'am, this has also become a bundle of 10. Good. Now we have 4 bundles of tens. Who will count further? I will count 1, 2 and 3. Here is the 5th bundle of tens.
Hey Billy, what is this?
Bundles of tens means that group must have 10 objects.
Here there are only 3 sticks, so we cannot make a bundle of 10 with them.
It means that to make a bundle of tens,
a total of 10 objects are to be kept in one group together.
Yes. How many groups of tens are there?
There are 4 groups of tens, meaning 4 tens.
4 tens means 40. Now besides the bundles of tens, how many sticks are left?
There are 3 sticks left. Adding 1, 2 and 3 to 40 makes 43.
Children, remember a group of tens mean a group of 10 objects.
Yes, ma'am. Children, today we learned interesting facts about forming two-digit numbers using bundles of tens. In the next video, we will learn adding numbers through grouping.
Kids, in this video, we will learn about use of appropriate unit to measure the length or distance between objects. When Chanda went on a trip with the villagers, she wrote the length of some items on a paper. Today, while Chanda was cleaning her house, the paper was accidentally torn. Now, Chanda is unable to understand which is the measure of what. Now, Chanda quickly wrote the names of the objects and places that were written on that paper on another paper like this. She then picked up a piece of paper from those pieces of paper with 1 meter length written on it. Kids, can you tell which of these items can be 1 meter in length? Absolutely correct. Peanuts and shoe are much smaller than 1 meter. It is possible that the length of the mat is 1 meter. Hence, the correct answer is length of the mat. Now Chanda found these two pieces of paper on which 4 centimeter and 22 centimeter were written. Now, can you match the length of the remaining two objects with their correct lengths? You can find the answer by pausing the video. Well done, kids! You have found the answers to them. Because the length of the peanut is much smaller than that of the shoe, length of peanut will be 4 centimeter and shoe length will be 22 centimeter. Kids, if Chanda had written the distance between the railway station and the well on a paper, which of the following could it be? If you want, you can pause the video and find the answer. Well done, kids! You have found the right answer. Because the distance from the railway station to the well is very long. We cannot measure it in centimeters. Therefore, the distance from the railway station to the well will be 3 kilometers. After all, Chanda got all the measurements written by her to match. See how she's dancing happily. Children, in this video, we learned about which units can be used to measure the length or distance between objects. In the next video, we will learn more about it with some interesting examples. Kids, in the previous video, we learned to use the appropriate unit to measure the length or distance between objects. In this video, we will learn more about it with some interesting examples. Raju's father asks him to bring a piece of cloth for his shirt from the duck uncle's shop. On the way, Raju met Bablu and they went to the park to play. Raju totally forgot about bringing the cloth for his father's shirt. When he was returning home, he remembered that he had to go to the uncle's shop. But he only remembered the number 2 from the measurements his father had given him. Kids, can you tell Raju that what units should be used to measure the cloth for his father's shirt? Centimeters, meters, or kilometers? Which one should be used? Well done, kids. Your answer is absolutely correct. Raju should use meter for the piece of cloth for his father's shirt, because the 2 centimeter measure would be too short and 2 kilometer would be too long. Raju immediately reached the uncle's shop and bought a 2-meter long cloth for his father. When Raju was returning home, in a shop on the way, he saw a computer monitor like this. On the monitor, the screen size was written in this way. But only the number 45 was written below that. Raju came to know that the length of the screen of the monitor was 45. But Raju did not understand which unit was used for it. Children, can you tell, for the length of the monitor screen, which unit should be used next to 45? Absolutely correct. Because both 45 meters and 45 kilometers would be very long. Raju should write the length of the computer screen using centimeter. So in this way, what would be the screen length of the monitor? 45 centimeter. Now Raju was about to reach his house. Just then, on the way, he saw it was written on a stone plate on the ground, Pampapur 40. But the unit below was erased. Raju started thinking that the distance from Pampapur to there was written on that stone. Now which unit should be written in front of 40 so that the people going there can get the correct idea of distance to Pampapur? Kids, can you help Raju? Well done, kids. You have found the correct answer. Because the distance between places is very long. We cannot write them using centimeters or meters. Hence, the distance from there to Pampapur will be 40 kilometers. Raju found the right answer with your help. Then, he took a piece of coal and wrote 40 kilometers in this way and returned to his home. Kids, in this video, we have learned about some interesting examples in which appropriate unit is used to measure the length or distance between objects.
children, in this video, we will learn how we can measure the capacity of a pot in liters. The pure milk of Golu's dairy has become so popular that every day there is a long queue at the dairy. It takes a lot of time to measure the milk for every customer using the 1 liter measure. Golu is wondering how he can sell milk to his customers in the shortest time possible. That's when Golu got an idea. Golu wondered why not he fill the bottles and cans of different capacities in advance. By doing this, he will be able to sell milk to his customers very fast. Golu has bottles in 2 sizes and large cans like this. Golu first took 1 bottle of this size. He poured milk into the bottle using his 1 liter measuring scale. The bottle was this full after pouring 1 liter of milk. Now Golu poured 1 more liter of milk with his liter scale into that bottle. This time the bottle was completely full. Children, can you tell what is the capacity of this bottle? That's right. The capacity of this bottle is 2 liters. Golu immediately filled all similar bottles and put a 2 liter sticker on them in this manner. Now Golu took 1 bottle of the other size and started filling it with his 1 liter milk measuring scale. After pouring 1 liter of milk in the bottle was this full. Children, can you guess what the capacity of this bottle is? The capacity of this bottle is 1, 2, 3, 4, and 5 is 5 liters. Golu immediately put stickers of 5 liters on bottles similar to these. Now Golu began measuring the capacity of such a can with his 1 liter milk measuring scale for large customers such as Appu. The can is this filled by 5 liters of milk. Children, if the can is this filled with 5 liters of milk, then what is the capacity of this can? If required, you can pause this video and find the answer. Well done! Your answer is absolutely correct. After pouring 6, 7, 8, 9, and 10 liters of milk, the can was fully filled. Hence, the capacity of this can is 10 liters. Now, Golu put a 10-liter stickers on these cans and happily closed his shop and returned back home. Children, in this video, we learned about how we can measure the capacity of bottles in liters. We will learn more about it in the next video. Hello children, in the previous video we learned about how we can measure the capacity in liters. In this video we will learn more about it by using some interesting examples. Bunny and Bhola are going to school. The two suddenly start fighting about who is smarter. Bunny said to Bhola, "Bhola, I am smarter than you." Then Bhola said to him, "Is that the case? Why don't we ask the Badbola uncle who among us is smarter?" "Tell me, uncle, I am smarter or Bhola?" Bunny asked Badbole uncle. "This is very easy. I will ask both of you some riddles. Whoever gives the correct answer to most of the riddles will be considered smarter." But Bole uncle said to Bhola and Bunny. Bunny and Bhola agreed. Uncle's first riddle is this. There are two pots here. The yellow pot's capacity is twice as much as the blue pot. The blue pot has a capacity of 3 liters. So tell me, what is the capacity of the yellow pot? Bunny and Bhola started doing their math in their minds. Then Bhola immediately said, 6 liters. Bunny is shocked. How Bhola finds the answer so quickly? Children, is Bhola's answer correct? Let's see how Bhola found this answer. We know that the capacity of the blue pot is 3 liters and the capacity of the yellow pot is twice that of the blue pot. In this way, the capacity of the yellow pot will be 2 times 3, which is 6 liters. Bhola's answer is absolutely correct. Your answer is absolutely right, Bhola. Now let us see who answers the next riddle correctly. If Chanda has a bucket with 2 liters capacity and she uses it 5 times to fill Golu's bucket, then what is the capacity of Golu's bucket? Bunny and Bhola once again started doing math in their minds. This time, Bunny answered first. 10 liters. Children, is Bunny's answer correct? The capacity of Chanda's bucket is 2 liters. And to fill Golu's bucket completely, Chanda fills her bucket 5 times. In this way, the capacity of Golu's bucket will be 5 times 2, which is 10 liters. Bunny's answer is absolutely correct. Your answer is absolutely right, Bunny. Look, children. Bhola answered one riddle correctly, and Bunny also answered one riddle correctly. So, both of you are smart. Uncle told Bhola and Bunny. Bhola and Bunny understood what the uncle said and happily went to school. Children, in this video, we have learned about how to measure the capacity in liters through some interesting examples. In the next video, we will learn some misconceptions about it. Hello children. In the last video, we learned how to measure the capacity in liters through some interesting examples. In this video, we will look at some of the misconceptions related to this. Raju and Bablu have come to Bhola's shop to buy oil. Both of them have brought a pot from their homes. Bhola first poured oil in the 1 liter bottle and poured it into Raju's pot. Raju's pot was completely filled. Now Bhola filled his 1 liter bottle completely with oil and poured it into Bablu's pot. But what's this? Bablu's pot is only half full. Raju immediately said to Bablu,
Look, Bablu, my pot is completely filled, but your pot is still empty. My pot has more oil than yours.
Children, is Raju right? Does his pot has more oil than Bablu's pot? Bhola listened to Raju and took the pots from both of them and emptied them completely. Now Bhola poured oil from 1 liter bottle into Bablu's pot. Bablu's pot is half full. Now Bhola poured oil from his 1 liter bottle again into Bablu's pot. In this way, how many liters are there in Bablu's pot? Exactly. Bablu's pot has a capacity of 2 liters. Now, Bhola poured oil in Raju's pot by filling his 1 liter bottle. Raju's pot was completely filled. Children, can you tell what is the capacity of Raju's pot? Yes, Raju's pot has a capacity of 1 liter. Children, can you now tell whose pot's capacity is more? Raju's pot has a capacity of 1 liter and Bablu's pot has a capacity of 2 liters. So the capacity of Bablu's pot is more than the capacity of Raju's pot. Children, here are some utensils and their different capacities. Can you place them in order of their capacity? If you want, you can stop the video and find the answer. Well done! Your answer is absolutely correct. The capacity of the half-liter jug is the lowest and the capacity of the 1000-liter water tank is the highest. Children, remember, it is not necessary that if it looks like a vessel is full, then its capacity is more. As you have seen here, Raju's pot is completely filled with 1 liter oil, and Bablu's pot seems to be empty even after pouring 1 liter of oil. Even though looking at these two pots, you feel that there is more oil in Raju's pot. But actually, when we compare their capacities, we found that Bablu's pot has more capacity than Raju's pot. Therefore, Bablu's pot will hold more oil than Raju's pot. Bhola explained this to Raju and Bablu, and both thanked Bhola for this. Raju and Bablu gave Bhola the money for the oil and returned to their houses with their own pots. Children, in this video, we saw some misconceptions about measuring the capacity in liters.
Raju's school was celebrating Family Day today. One by one, each student was introducing their whole family to the class. Raju also came to the school with his entire family. When it was his turn, Raju stood in front of the class with his family and introduced everyone.
This is my father. My father's name is Prakash. This is my mother. Her name is Kavita. This is my younger sister. Her name is Deepika. We affectionately call her Deepu. And this is my grandmother. She is the eldest in the house. Her name is Lalita Devi.
The class was happy to meet Raju's family. Before leaving the school, they got a family picture clicked and came back home. Come, let's take a close look at Raju's family photo. Think, what is the relationship between different members of the family? They are husband-wife. They are father-son. They are mother-daughter. They are brother-sister. They are grandmother-grandson. They are mother-son. Similarly, think, how are the different members of your family related to each other? Come, let's look at the picture again. Deepika's eyes are like her mother's. Raju and his father's hair are similar. They both also like the same kind of food. There are many similarities between the members of a family. Who do you look like in your family? Who has the same habits as you? The doorbell of Raju's house rang. Let's see who is at the door. She is Pushpa. She helps clean and wash Raju's house. Pushpa stays in a little colony outside the city. There are many members in her family. Father, mother, 2 brothers, a younger sister and a cousin. Pushpa started working as soon as she finished school. Everyone in her family does some work or the other. Her father is a washerman. Her mother and brother iron clothes for a living. Her younger brother and sister go to school. Her cousin is a wage laborer in the city. Everyone in her family helps each other in domestic chores. Our family is our first school. We learn so many things from our family members. Raju learned how to cook from his mother. He learned many stories from his grandmother. Pushpa's cousin taught her how to ride a bicycle. She learned many folk songs from her mother. Both learn about principles, values, and ideal behavior from their families. There are some rules and traditions in Raju and Pushpa's houses. In Raju's house, talking loudly is frowned upon. In Pushpa's house, no one is allowed to enter the kitchen with their footwear on. Are there any rules and traditions in your house? What are they? When Raju is upset, he consults his father. When he wants to learn something new, he asks many questions to his mother or father. Pushpa loves playing with her younger sister. She forgets all worries and fatigue while playing with her. Both Pushpa and Raju are immensely attached to their families. They respect their elders and help in the household work. Raju helps in the kitchen. Pushpa helps her father buy groceries from the market. Today, we saw and learnt about the people in Pushpa and Raju's families and how our different members related to each other. We understood that physical features and habits of family members often match. We learn many things from our family members and we are attached to them. Among important family values are respect for elders and affection for the younger ones. We learn about right and wrong, traditions, behavior and values from our families. So children, think, what all do you learn from your family? After all, your family is your first school.
Depth of objects. Part 1. Today we will learn how to measure the depth of objects. Vandana, don't go to the park to play during the rainy season. Play here at home.
Why, Papa?
I went for a walk in the park this morning and noticed that the constant downpour has formed deep pits in the park, and you may hurt yourself while playing.
Okay, Papa. But how deep are the pits?
I didn't have the scale, but it seemed to me about 15 centimeters to a meter deep.
15 centimeters to 1 meter. But usually centimeters and meters are used to measure the length and width. Why are you telling the depth in centimeters and meters, Papa?
Because depth is also measured in meters, centimeters and kilometers.
Can you please explain, Papa? I did not understand.
Look, Vandana, different qualities of objects are measured. The length, width and height of a brick is measured. In the same way, the depth of the pit is measured.
What are the objects in our house whose depth can be measured?
There are many objects in our house whose depth can be measured. Look at that cupboard. The depth of a cupboard is very useful measurement because more the depth of a cupboard is, there will be more space for storage.
Oh, so it is not necessary that we only measure the depth of those objects which are below ground.
Yes, Vandana. For instance, depth is also measured in kitchen utensils because they are filled with goods. The deeper the utensil, the more quantity it can hold. The depth of a vessel helps in determining what could be stored in it.
What are the other objects whose depth can be measured?
Look, you have already discovered examples of pits, cupboards and kitchen utensils whose depth is measured. Similarly, the depth of the well is measured. The depth of the sea is measured. The depth of the pond is measured and the depth of a planter is also measured.
Okay, and the depth of all these is measured in centimeters and meters?
Yes, and it can be measured in kilometers as well.
Distance is measured in kilometers. What can be so deep to be measured in kilometers, Papa?
Do you know, Vandana, there are some areas in the sea which are more than 3 kilometers deep.
More than 3 kilometers deep. This is too much.
There are many objects in nature which surprise us. In the next class, you will study about these objects. Now tell me whether you understood what centimeter, meter and kilometer can be used to measure.
Yes, Papa. The length, width, height, depth and distance of objects are measured in centimeters, meters and kilometers.
Today we learned centimeter, meter and kilometer units are used to measure the length, width, height and distance of objects, and how to measure the depths of objects.
Relation between liter and milliliter. Today, we will learn about the relation between measuring units of liquid, liter and milliliter. Hello, I am Wise Owl. Welcome to the forest. All the animals of the forest come to me for suggestions and advices. Today, I will tell you about the units, liter and milliliters to measure liquids. Hey, you all are panting. From where are you all coming?
We were playing in the forest and we are running from there only. We all are very thirsty. Would you please give us some water?
Yes, sure. You all will get water.
I will drink 1 drum of water. I want a bucket of water. I will drink a big vessel of water.
I want a bowl of water.
Thanks for giving us water. We all were very thirsty.
Friends, I hope all of you have quenched your thirst.
How many kilograms of water did you drink?
Hey, liquids are not measured in kilograms.
Then how?
We measure liquids in liters and milliliters.
What is liters and milliliters?
Liters and milliliters are units used to measure liquids. There are 1000 milliliters in a liter.
1000 milliliter?
Yes.
I drank 1000 milliliter of water.
You have drank more than 5 liters of water, nearly about 5 liters.
Did I also drink more than a liter of water?
No, Cat Queen. You have drank even less than half a liter of water. Let me explain this to you in some detail. Look carefully at these vessels and fill these blanks according to the given measurement. Kids, you can pause the video to find out the answer.
First, I will tell.
Tell.
Drum, because it is the largest of all and can carry 200 ml of liquid. Oh no. Just now Sir has told that milliliter is smaller than liters. 1000 milliliters makes 1 liter. So 2000 milliliter is much less than 1 liter.
So, according to you, what will be the right answer?
According to me, a drum has a capacity of 20 liters.
Very good.
Okay, so the capacity of bowl will be 200 ml.
Right. Now you all have got it.
Capacity of bucket is 5 liters. And capacity of utensil is 2 liters.
Very good, kids.
Sir, please show some more examples.
Look, I have 2 bottles of cold drink and these empty bottles of 1 liter and 100 milliliter. Now you try to pour this cold drink in this empty bottle.
We cannot put 500 ml in a 100 milliliter bottle.
Now try to put this in the empty bottle of 1 liter.
Oh, it became full now.
Yes. So what have we learned from this?
2 500 liters of bottles make a liter.
Yes, right. Means on adding 500 milliliter to 500 milliliter, we get 1000 liters. 500 ml is also known as half a liter.
Sir, can you give some more examples?
Okay. I will recite a story to all of you. Pinky and Bholu live in the village with their parents. Pinky and Bholu got very thirsty while returning from school.
Mom, I'm very thirsty.
Okay, I'll make lemonade for everyone.
We will also help you in making lemonade.
Mother makes 1 liter of lemonade with the help of Bholu and Pinky and fills it in 4 glasses.
Okay, I'll make lemonade for everyone. Now tell me, if I divide 1 liter of lemonade into 4 equal parts, how many quantity of lemonade will everyone get?
400 ml.
No, this is not right. You tell, Bholu.
I don't know. Please, you explain, Mom.
How many milliliters are there in a liter?
1000 milliliters.
Correct. Now if I fill these 2 glasses, then how much lemonade will be left in the jug?
Half the jug is still full.
What is the half of a liter?
Kids, you can pause the video and think about the answer.
ml.
This means 2 glasses contains 500 ml of lemonade.
Yes, Mom.
Can you tell how much lemonade is in 1 glass?
Half of 500 ml.
Very good. So what's that?
Kids, you can pause the video and think about the answer.
We have to divide 500 by 2. 250?
Very good, Bholu.
Daddy, we all got 250 ml of lemonade.
Meanwhile, two friends of Pinky arrive. We should give lemonade to our friends too. Why don't we share a part of our lemonade with them?
Look, in total we have 2 glasses of lemonade.
Then how much lemonade will we all get?
As Mom explained, we have 500 ml of lemonade.
You mean half a liter?
Yes, let's divide 500 by 4.
Kids, you can pause the video and think about the answer.
Look, we all will have 125 ml of lemonade.
Oh wow, Pinky! You have solved this too quickly.
Today, we have learnt about the relation between measuring units of liquid, liter and milliliter. Relation between liter and milliliter. In the last video, we have learnt about the relationship between liter and milliliter. In this video, we will learn about how to make 1 liter by combining different units. Do you know? Mixing 500 ml twice gives 1 liter.
Yes, sir.
Are there any other units which on adding gives 1 liters?
Sir, ask a bit more clearly. I couldn't understand.
For example, do you think that glasses of 250 ml can be combined to form 1 liter?
Yes, it can be made. No, I don't think so. 1 liter can be made out of 250 ml.
So, let's see how 250 ml and other units can be combined to form a liter. These two glasses have 250 ml of water. If both of them combines, how much water will we have?
500 ml water.
Yes, you are right, elephant. If we combine 2 more glasses of 500 ml water in it, then how much total water will we have?
500 milliliter and 500 milliliter means 1000 milliliter means 1 liter.
Yes, correct. Now see, in one bottle, we have 200 ml of oil and in the other, we have 300 milliliter of oil. Now tell me, to fill 1000 milliliter bottle or 1 liter bottle, how much oil will you need?
Is the answer 400 ml?
Look carefully. On adding, it gives 500 milliliter. So adding one more 500 milliliter will form 1 liter.
Bholu, your answer is right. Now tell, how many 100 milliliters will add up to 1 liter?
Adding 100 ml up to 10 times makes 1000 milliliter. Means 10 multiplied by 100 milliliter gives 1 liter.
Now, answer one more question of mine. This bottle contains 200 ml of water. How many times 200 milliliter bottles should be added to give 1000 ml of water?
I know that adding 200 milliliter for 5 times give 1000 milliliter or 1 liter. So, if in this bottle we pour 200 milliliter of water for 4 times, then it will become 1 liter.
Very good, elephant. 5 times will make 1 liter. See this. We have 400 milliliter of milk. we need 1000 milliliter or 1 liter milk. Now look, these are the packets of 200 milliliter, 300 milliliter and 400 milliliter. Which three identical packets will combine to make 1000 milliliter?
Is the answer 300 ml? On combining, I think it will make 1000 ml.
I think the correct answer is 200 milliliter. Mixing 3 packets of 200 milliliter makes 600 milliliter. And mixing these 600 ml with 400 ml will make 1 liter.
Yes, right. We can see that not only 500 milliliter but many more units can be combined to form a liter.
Yes, sir. We got it.
So kids, today we have learned how to make 1 liter by combining different units.
Meaning of half, 1/4 and 3/4, Part 1. Today we will learn how half and quarter are written in mathematics. I am not very hungry today. I will eat only a quarter of this paratha. You can eat the rest. Okay, I am taking these 3 parts. Now I will eat a quarter of this paratha. But how will we find out how much portion of this paratha did you eat? I would say that I ate 3/4 of a paratha. This has become very difficult. I think there will be some way of explaining this in mathematics. How is this related to mathematics? Oh, it is related to mathematics. Half, 1/4, etc. Neha, these all are numbers. Numbers are like 1, 2, 3, etc. Half and quarter are not numbers. Right, Ayushman? I think these two are numbers. Neha, let's ask our teacher after having our lunch. We can then find out for sure. Okay. Hello, ma'am. Hello, Neha and Ayushman. Tell me, what do you want to learn today? Madam, we want to know whether half and quarter are also numbers. Can you explain? Yes, Ayushman, these two are numbers. But half and quarter are written in words. If these are numbers, then why don't we write them in numbers? They are also written in numbers. Writing in digits also make it easier to add and subtract them. How are they written in numbers, madam? I will show you how. Look, this is a rectangle. When it is divided into 2 equal parts, then one part is called half of this entire shape. Yes, ma'am. But ma'am, how to write it as a number? Very easy. First, we will see how many parts of the whole object are there. There are a total of 2 parts of this entire rectangle. Yes, and we will draw a line to show it and write 2 below it. Now tell me, how many of these 2 parts will be called half? Madam, one of these 2 parts will be called half. Absolutely right. So we will put 1 above this line. What does it mean? It means 1 out of 2 parts. But how do we read it? It is read as 1/2. That is 1 out of 2 parts. And how do we write quarter? Exactly like I have written half, you can also write quarter. Let me try.
1 out of 4 equal parts of this figure is called quarter. To write this, we will first draw the line of division and then write the total number of parts of the figure in it. There are a total of 4 parts of this figure. Therefore, we will write 4 under the line and 1 out of these 4 will be quarter. So, we will write 1 above the line. That means to write a quarter, we have to write 1 out of 4. You both have given the right answer. Madam, we made 4 equal parts of the paratha. If I ate 1 part of them, I can write 1/4 of the paratha. But Neha ate 3 parts. Then how will she write it? This is also very easy. First, draw the line of division. Write down the total number of parts below the line, that is 4. Now write down the number of parts that Neha ate of the paratha above the line, that is 3. So we can say that Neha has eaten 3/4 of the paratha. 3 over 4 is also called 3/4. Well, I ate 1/4 of the paratha and Neha ate 3/4 of the paratha. Yes, Ayushman, now you have understood. Now practice it, and if you face any problem, then come to me. Okay, madam. In this video, we have learned that half, quarter, etc. are also numbers and they can be written in digits. And whenever some part of the entire object is to be shown, then the line of division is used. The total number of parts in which the object is divided is written under the line. And the number of parts out of the total is written above the line. For example, to show half of an object, 1/2 is written, which means 1 part out of 2. And 1/4 is written for 1/4, which means 1 part of 4.
Eating Together, Part 2. Midday Meal. In the previous video, we learned about the Bihu festival in Assam. Introduction. In this video, we will learn about the midday meal served at school. Today, Bittu takes a quick shower and gets ready to go to school. He is waiting for the school bus. That's when his grandpa comes home after a morning walk.
Bittu, you got ready? But you only have a bottle of water in your hand. Where is your lunch box? Won't you eat food at school today?
Why do I have to carry food, Grandpa? We get midday meals in our school.
Midday meal? What is that?
Midday meal is the lunch we get every day at school.
Does your school also serve midday meals? At what time is the food served to you in school?
All the children go and wash their hands as soon as the bell rings during lunchtime every day. Then they sit outside the kitchen to eat.
That's a very good thing, Bittu. We should always eat food only after washing our hands with soap.
Do you also eat food after washing your hands?
do you wash your hands with soap?
We sit at different places every day while eating at school, due to which we also make new friends.
But Bittu, what is there in the midday meal?
We get different things every day. We get lentils, rice, vegetables, roti, and sometimes kheer also. We get our food according to the menu for each day, which is written on a board.
How do you like this food, Bittu?
I like this food very much now. But a few days ago, this food did not taste that good.
Why is that, Bittu?
Earlier, rice and other food items made from it contained tiny stones which could have broken our teeth. Then one day, Meenu's father complained about this to the school. After that, the school started serving better food.
If you feel there is an issue with the midday meal, then where will you file your complaint?
That's very good. Anyway, we should always eat clean food.
Yes, Grandpa, you are absolutely right.
While Bittu and Grandpa were talking, Bittu heard the honking of his school bus.
Grandpa, my school bus has arrived. I need to go now. Today, we will get egg curry with roti in our school.
Good, Bittu. Go carefully. And along with eating, do some study in school also.
Bittu smiles and leaves for school. Summary: in this video, we learned about the midday meal served at school.
Hello kids! In this video, we will learn about estimation and verification of volume of containers. Golu Panda has organized a unique competition in Champapur in celebration of his masala milk becoming very famous. Golu declared that whoever collects the most number of bottle caps of his masala milk bottles within 10 days will get a free masala milk bottle every day for a whole month. Everyone got excited and started collecting the bottle caps of Golu's masala milk bottles. Chanda is thinking,
I can win this competition if I collect 100 masala milk bottle covers within 10 days. But I need a big pot to keep so many covers. Now, how do I find such a container? What is the volume of utensil required to collect 100 pieces?
Just then, her eyes went to the measuring cup kept in her house.
Oh yes! With the help of this measuring cup, I will first find out what the volume of 10 bottle caps is. Then, I will be able to easily find out the volume of 100 bottle caps.
Chanda filled 50 milliliters of water in that measuring cup. Then, she put 10 covers in that measuring cup and the water level came up to 150 milliliters.
Well, first the water level was at 50 milliliters and now it has risen to 150 milliliters. That means the volume of 10 lids is 100 milliliters. And if the volume of 10 lids is 100 milliliters, then the volume of 100 lids will be 100 multiplied by 10, that is 1000 milliliters or 1 liter. I have to take a container of 1 liter volume.
Chanda immediately took a box of 1 liter ghee and started to collect the bottle caps of Golu's masala milk. Time passed by quickly, and soon it was the 10th day. All the people have collected different numbers of bottle caps. Children, if Babban has collected 30 bottle caps in his box and his box is only half full, can you tell what the volume of Babban's box is? If you wish, you can stop the video and think of the answer. The volume of 10 bottle caps is 100 milliliters and Babban has collected 30 bottle caps. This will mean the volume of the bottle caps collected by Babban is 100 times 3. That is 300 milliliters. But the volume of the bottle caps collected by Babban is half the volume of its container. Therefore, the volume of the box of Babban will be 2 times of 300 or 600 milliliters. Chanda collected the most number of bottle caps. She has gathered 100 bottle caps and she finally won the competition. Now, Chanda will get 1 masala milk bottle free every day for a whole month. Look how happily Chanda is dancing. Children, in this video, we learned about estimation and verification of volume of containers. In the next video, we will learn more about it by some interesting examples. Hello kids! In the last video, we learned about estimation and verification of volume of containers. In this video, we will learn more about it by some interesting examples. Raju and Bablu are collecting coins.
Raju, I will collect 1 rupee coins.
I will collect 5 rupee coins, Bablu. Let us buy boxes from the market to collect coins in.
But Raju, how do we know what is the volume of the boxes we will need to collect 100 coins? And I don't even have a measuring cup at my house.
Never mind. We can make our measuring cup.
Wow! How's that?
Bablu, do you have an empty bottle or a jug?
Yes, I'll get it right away. Look here, Raju. I have this 20 milliliter bottle and I have brought this jug too. But what will you do with them?
I will tell you now. First, we will fill this empty bottle completely with water. Then, we will empty the bottle in this jug. Because the volume of the bottle is 20 milliliters, we can say that the jug currently has 20 milliliters of water. With a pen, we will mark 20 milliliters of water in this jug at that level of water.
Bablu quickly made a mark of 20 milliliters at the level of water filled in the jug.
Now, we will fill the bottle completely every time and empty it in the jug, and each time a mark will be made on the jug by adding 20 points to the previous level of water. In this way, the marks on the jug will be made at 40, 60, 80 milliliters. See, Bablu, our measuring jug is ready. Now we can use it to find the volume of the coins.
Oh wow, Raju! This is a wonderful technique. Let us find out the volume of 10 1 rupee and 10 5 rupee coins.
Raju and Bablu used the measuring jug made by them. They found that the volume of 10 1 rupee coins is 20 milliliters and the volume of 10 5 rupee coins is 40 milliliters. Children, can you now find out what would be the volume of the boxes which can be used by Raju and Bablu in order to store 100 coins of 1 rupee and 100 coins of 5 rupees? If you wish, you can stop this video and think of the answer. The volume of 10 1 rupee coins is 20 milliliters. Therefore, the volume of 100 1 rupee coins will be 20 times 10 or 200 milliliters. And the volume of 10 5 rupee coins is 40 milliliters. So, the volume of 100 5 rupee coins will be 40 times 10 or 400 milliliters.
Raju, come, let's quickly go to the market and buy one box having a volume of 200 milliliters and one box having a volume of 400 milliliters.
Both the friends excitedly walked towards the market. Children, in this video we learned about estimation and verification of volume of containers by some interesting examples. In the next video, we will look at some of the misconceptions related to this. Hello children, in this video we will learn to estimate area using grid paper. Golu, Bunny and Bhola bought different types of biscuits from the market.
Bunny, Bhola, look at my biscuit. It is bigger than your biscuit.
Golu said to Bunny and Bhola.
No, my biscuit is bigger than the two of you.
Bunny told Golu.
Friends, we can immediately find out whose biscuits are the biggest using grid paper,
said Bhola. Bunny and Golu could not understand anything. Then Bhola made such equal-sized squares on a paper.
A paper made of equal-sized squares like these is called a grid paper,
said Bhola.
But Bhola, how can we use this to find out the biggest biscuits?
Golu asked Bhola. Bhola made the outlines of those 3 biscuits with a pencil on the grid paper.
Bunny, can you tell me how many squares are there in the shape of your biscuit?
Bhola asked Bunny. Bunny quickly counted the number of squares and said,
16 squares. And Golu, tell me how many squares are there in the shape of your biscuit?
Bhola asked Golu.
15 squares,
said Golu.
And can you both tell me how many squares are in the shape of my biscuit?
Bhola asked Bunny and Golu.
24 squares?
24 squares? Said Bunny and Golu, shocked.
Absolutely right. And do you know that the area created inside the boundary of any shape is known as the area of that shape? So, we can say that the area of my biscuit is larger than the area of both your biscuits. Or, my biscuit is bigger than both of your biscuits.
Bhola explained to Golu and Bunny.
This is such an interesting thing you have taught us, Bhola. Let us all share our biscuits and eat them.
Bunny said to Bhola. The three friends shared their biscuits and ate them with great pleasure. Children, in this video, we learned to estimate area using grid paper. In the next video, we will learn more about it through some interesting examples. Hello children! In the previous video, we learned to estimate area using grid paper. In this video, we will learn more about it through some interesting examples. Raju and Bablu are watching TV at Bablu's house.
Painting competition has been announced in Champapur. All the contestants have to make unique paintings. The most unique painting will be rewarded.
This is being shown in the news on TV.
Raju, why don't we make a painting on a leaf?
Bablu said to Raju.
Yes, Bablu, this is a very good suggestion. Let us both find one leaf and then whichever leaf is bigger, we will together make a beautiful painting on it.
Raju told Bablu. Both friends began to find leaves outside Bablu's house. Both Bablu and Raju found one leaf each.
Bablu, we should use the bigger of these two leaves to make our painting.
Raju told Bablu.
But how will we find that out?
Bablu asked Raju.
All we need to do is to find the area of these two leaves. The leaf which has more area is bigger.
Saying this, Raju created outlines of both the leaves using a pencil on a grid paper.
But Raju, the areas enclosed by the outline of these leaves have some full squares, some half, some more than half, and even some less than half squares. Then how are we going to find their area?
Bablu asked Raju.
It is very easy. Can you tell me how many full squares are there in the area of the first leaf?
Raju asked Bablu.
8 squares.
Bablu quickly counted. Raju wrote down the number of full squares in this way.
Now, can you tell me how many half squares are there in the area of the first leaf?
Raju asked. Bablu looked closely and said,
6 squares.
6 half squares. We can even write them equal to 3 full squares.
Raju added 3 to the number of full squares previously written.
And now, finally, can you tell me how many squares are more than half in the area of the first leaf?
Raju asked.
2 squares.
Bablu said excitedly.
Absolutely right. We'll count them as full squares.
Now Raju added 2 more to the number of full squares.
We will not count any squares which are less than half. Now look, Bablu. The area of the first leaf has a total of 8. Add 3 plus 2 or 13 squares. In other words, there are 13 squares in the area of the first leaf. Bablu, can you now use this process to find out how many squares are there in the area of the second leaf?
Raju told Bablu. Children, can you help Bablu in finding the answer? If you wish to, you may stop the video and find the answer. The area of the second leaf has 10 full squares, 4 half or 2 full squares, and 4 more than half squares. And there are some less than half squares which we will not count. In this way, there are 10 add 2 plus 4 or 16 squares in the enclosed area of the second leaf. In other words, there are 16 squares in the area of the second leaf. Bablu also found the answer to this question just like you.
Raju, there are 16 squares in the area of the second leaf and 13 squares in the area of the first leaf. This means that the second leaf is larger than the first leaf.
Bablu told Raju.
Well done, Bablu. We came to know which is the biggest leaf, and you also learned to find the area using a grid paper. Now, let us quickly take part in the competition by painting a beautiful picture on this bigger leaf.
The two friends made a beautiful painting on the second leaf. Children, in this video, we learned more about estimating area using grid paper through some interesting examples. In the next video, we will look at some of the misconceptions related to this. Hello children! In the previous video, we learned more about estimating area using grid paper through some interesting examples. In this video, we will look at some of the misconceptions related to this. Chanda wants to open a new restaurant. Chanda has to buy new plates for her restaurant. She has come to buy plates at Gaggu's shop.
I want to buy the biggest plates,
Chanda told Gaggu. Gaggu showed plates of these shapes to Chanda and said,
Chanda, all these plates are of new designs, and in all these you can serve exactly the same amount of food.
But how is that possible, Gaggu? This plate is triangular, this one is square-shaped, and this plate is rectangular. Because rectangle is bigger than square and triangle, the rectangular plate is bigger than both these plates,
Chanda said to Gaggu. Gaggu laughed and said,
No, Chanda, come, let me explain this to you using this grid paper.
After saying this, Gaggu used a pencil to trace the outlines of the 3 plates onto the grid paper.
Chanda, can you tell me how many squares are there in the area of the rectangular plate?
Gaggu asked Chanda. Chanda quickly counted.
16 squares.
And how many squares are there in the area of the square-shaped plate?
Gaggu asked.
That's 16 squares too,
Chanda said shocked.
And now can you tell me the number of squares in the area of this triangle-shaped plate?
Children, can you help Chanda find the answer? If you wish to, you may stop the video and find the answer. There are 12 full squares in plate. Chanda too found the area of the triangle-shaped plate just like you.
Hey Gaku, there are 16 squares in the area of this triangle-shaped plate too. You are right. The shapes of these plates may be different, but their areas are exactly the same.
Chanda said to Gaggu.
The plates of these three shapes are very beautiful. Give me plates of all these three shapes,
said Chanda, and then bought plates of all three shapes from Gaggu. Children, in this video, we learned about some misconceptions related to estimating area using grid paper.
The Journey of Food from Taste to Digestion, Part 1. What happened, children? Is your mouth watering upon seeing me? You are all little children. Even the adults cannot control themselves to drool upon seeing me. Everyone likes to eat me and my friends, as we are not only tasty, but provide you with all the nutrients which are required for your health and growth. A few of my friends also take care of your taste buds, and that is why you all like them a lot. But if these food items are eaten in adequate quantity, they will never harm you. Today in this video, I will take you through the journey of food in your body.
Hey friends, there is a fair in our village today. Let's all go there. Wow, a fair? Let's go. It is going to be fun. We shall eat chaat, golgappe, play on swings, buy bangles, bindis. Let's go soon.
They all reached the fair and played on the swings. Had fun.
Let's go and eat pani puri. My mouth is watering at the mere mention of its name. Before eating these yummy golgappas, I can begin to get the tangy taste in my mouth. I like the tangy taste. What taste do you like, Geeta? Oh, these are very spicy. I will have to eat something sweet quickly. I am relieved after eating something sweet. How is it possible for our mouth to differentiate between the various tastes?
Meenu starts thinking, how does her tongue do this amazing job of differentiating between tastes? How do we come to know about the different tastes like sweet, spicy, bitter and sour? With this question in her mind, Meenu returns home with her friends. Meenu asks her mother her question.
Mother, how can we know about the taste of something sour before eating it? Or how is it that certain food items provide us with their taste without tasting them?
Mother thought for some time, then said,
Go and call your friends, Meenu. I will do a fun experiment with all of you to answer your question.
Meenu goes running to call her friends. When all of them arrive, Mother was in the kitchen and she had displayed a few things.
All right, children. How is the taste of this?
Raw mango, sour, very sour.
I like this taste a lot.
Okay, children. How is the taste of this?
Red chili? My God! It's very spicy. I do not like the spicy taste.
Children, there is a tongue in our mouth. There is a specified place for each taste like sweet, salty, sour, bitter. Ramesh, open a big mouth, beta, and show your tongue.
Ah!
Children, next time you eat something, remember the different taste buds on your tongue. Meenu's mother had boiled some eggs, and Geeta and Meenu did not like the smell of the eggs, while Ramesh was unaffected by the smell of the boiled eggs.
Ramesh, how is it that you do not dislike the smell of boiled eggs?
Meenu, I have a blocked nose because of cold.
Look, children, when we have cold, our nasal passages are blocked, hence we cannot smell things properly. This is the reason that Ramesh cannot smell the boiled eggs. There are a few things like boiled eggs, fish, pakore, samosas, whose smell make us get their taste on our mouth.
Yes, mother, like the bitter medicine you give me when I am unwell.
I shall give you an idea. Next time, whenever you have to take a medicine, close your nostrils with your hand. This way, you will not smell the medicine and it will not taste too bitter as well.
Friends, you also try the idea Meenu's mother has suggested.
With the mere mention of the medicine's name, my mouth has become bitter. Mother, please give us the fruits father had brought.
Sure, I will just give you the fruits.
Mausi, some fruits are so hard.
Yes, children, certain fruits are hard. There is saliva in our mouth which mixes with food and softens it and gives us taste.
My grandfather advises that we should eat our food slowly and chew it well, or else our stomach will ache.
Absolutely right. We don't have to chew soft food. However, hard food items like guava, roti, we have to chew properly. We should chew our food 32 times so that it mixes well with saliva and goes easily down the food pipe into the stomach.
What? 32 times?
Children, you should also chew your food at least 32 times.
Mausi, today you have provided us with meaningful information about different tastes. Thank you.
Mausi, I want to ask you a question. What happens when food travels from our mouth to our stomach?
Now we shall talk about this later. It's almost evening and your mother would be waiting for you.
All right, Mausi. Then let's meet tomorrow. I'm curious to know more about this wonderful journey of food.
Children, I hope you liked this video and the information provided in it will prove useful to you. In the next video, we will discuss about digestion. Till then, stay healthy, eat healthy.
Today we will see examples of intersecting lines and parallel lines.
Of the given figures, which one is an example of intersecting lines and which one is an example of parallel lines? The two lines in figure A do not intersect at any point. Even if we extend those lines, they will not intersect at any point. Lines that do not intersect are called parallel lines. Therefore, the lines of figure A are parallel lines. The lines of figure B intersect at a point. Lines that intersect at a point are called intersecting lines. Hence, figure B is an example of intersecting lines. Next example, find the pairs of intersecting lines and parallel lines in the figure given below. As we can see, the lines AC and BD do not intersect each other at any point. Even if we extend both the lines AC and BD, they will never intersect. Hence, the lines AC and line BD are parallel lines. Apart from these, there are no two lines in the given figure which are parallel lines. Now, let us find the pairs of intersecting lines in the given figure. If two lines intersect, then we call them intersecting lines. The following are the pairs of intersecting lines in the given figure. Line AB and line CA. They are intersecting lines because they intersect at point A. Line DC and line CA. They are intersecting lines because they intersect at point C. Line AB and line BD. They are intersecting lines because they intersect at point B. Line DC and line BD. They are lines of intersection because they intersect at point D. Apart from these pairs of lines, there is another pair of intersecting lines in the given figure. Can you find out? Think for a while. Let me tell you. Notice the line AB and the line CD. These lines in the figure may not intersect each other. But if extended, they will intersect at one point. As a result, we can say that line AB and line CD are also a pair of intersecting lines. Now you know about parallel lines and intersecting lines. So, try to solve the following questions yourself. Question 1. Find all those English alphabets made of parallel lines. Like for example, the alphabet E. On extending the lines, they never meet. Hence, it is made of parallel lines. Question 2. Find all those English alphabets made of intersecting lines. Like for example, the alphabet V. On extending the lines, they intersect. Hence, it is made of intersecting lines. Today in this video, we saw few examples of intersecting lines and parallel lines. In the next video, we will clear some of the misconceptions related to them. Today we will see some misconceptions related with intersecting lines and parallel lines. Misconception 1. Two lines are shown below. Find out whether they are parallel lines or intersecting lines. Lines that do not intersect are called parallel lines, whereas lines which intersect at a point are called intersecting lines. Some children memorize these interpretations. They do not understand their true meaning. As children see here that the given lines are not intersecting at any point, they think that the given lines are parallel lines. With this misunderstanding, option 1, the wrong answer is chosen. The correct understanding is that the lines can be extended on both sides. the lines in the figure do not appear to intersect, but if extended, they will appear to intersect at one point. Therefore, both lines are intersecting lines. That is, option 2 is the correct answer. Misconception 2. Which of the following is the correct pair of parallel lines? Many students understand that lines are represented in the first 3 options. They think that the pair given in each option do not intersect each other. Therefore, in all 3 options, a pair of parallel lines is represented. Therefore, they choose option 4, which is a wrong answer. In the given figure, observe option 1. There are no parallel lines. Rather, if we observe this, we get to know that this is a figure made of line segment and a ray. Since they are direct, therefore, option 1, 2, 4 are incorrect, and the correct answer is option 3. So today we have seen some misconceptions related to intersecting lines and parallel lines.
Today, we will learn about integers. We come across many situations in our daily life where there is a need to represent numbers with a positive or a negative sign. For example, the temperature of Mumbai is usually above 0 degrees centigrade and is represented with a positive sign before the number. During winters, do you know that the temperature of Srinagar falls below 0 degrees centigrade? This has a negative sign before the number. Similarly, in a building, the floors above the ground are shown by a positive sign, whereas the floors below the ground, like the basement, are shown by a negative sign. Numbers which have a positive sign before it are called positive numbers, and those which have a negative sign before it are called negative numbers. A collection of positive numbers, negative numbers, and 0 together is known as integers. In this collection, just numbers like 1, 2, 3, etc., without any sign, are said to be positive integers. Although -1, -2, -3, etc., which have a negative sign, are said to be negative integers. The value of negative integers is less than 0, whereas the value of positive integers is greater than 0. 0 is neither positive nor negative. Therefore, it cannot be represented by any sign. Now let's understand why integers are important. Let's understand it with the help of an example. Suppose a bird is flying at a height of 500 meters above sea level and a fish is at a depth of 500 meters below sea level. Can the distance between the bird and the fish with respect to land near the sea be represented mathematically? The height of the bird from the sea level is 500 meters and the depth of the fish from the sea level is 500 meters. But this is an incorrect way to represent their differences because both are situated in opposite directions. The bird is above the sea level, whereas the fish is below the sea level. Since whole numbers are incapable of representing this kind of situation, we use integers. In this case, the height above sea level is represented with a positive sign as plus 500 meters, and the depth below the sea level must have a negative sign such as minus 500 meters. It is now quite clear that plus 500 meters means 500 meters above the sea level and minus 500 means 500 meters below the sea level. Now let's consider some more examples of integers to understand it much better. Let's suppose Rahul and Ruchika start walking in opposite directions from a point, say 0. Rahul walks 5 steps towards the right from 0 and Ruchika walks 5 steps towards the left. How would you represent their distance from the initial point 0? Think about it. You are right. The steps towards the right are shown by a positive sign and those towards the left are shown with a negative sign. Therefore, Rahul has taken 5 steps and Ruchika has taken minus 5 steps. Now let's suppose Harsh came to a shop with rupees 30. But he bought things for rupees 35. He pays the shopkeeper rupees 30 and keeps a debt of rupees 5. How do you think the shopkeeper will make a note of this? Any ideas? Think about it. Okay, the shopkeeper should write minus 5 in front of Harsh's name, where the negative sign represents the money Harsh has yet to pay him. Harsh owes him rupees 5. Similarly, when money is deposited in a bank, it is represented by a positive sign, whereas withdrawal of money is represented by a negative sign. While we are discussing money, let's also talk about profit and loss. Suppose a businessman sells an article worth rupees 20 for rupees 25. His profit is rupees 5. Since his profit is rupees 5, it is represented as plus 5. But if he sells an article worth rupees 20 for rupees 15, he incurs a loss of rupees 5, which is represented as minus 5. Today, we have learnt about integers. In the next video, we will learn it in a better way with some examples. Today, we will see some examples of integers. Example 1. Following is the list of temperatures at 5 places in India. Represent them as integers. If the temperature is above 0 degrees centigrade, then it is represented as a positive sign. So the temperature of Delhi is 16 degrees above 0 degrees centigrade. Therefore, it is represented as plus 16 degrees. Similarly, Mumbai is 30 degrees centigrade above 0 degrees. Therefore, it is represented as plus 30 degrees centigrade. If the temperature is below 0 degrees centigrade, then it is represented as a minus sign. The temperature of Hemkund is 13 degrees centigrade below 0. Therefore, it is represented as minus 13. Similarly, that of Dras is 20 degrees centigrade below 0. Therefore, it is represented as minus 20 degrees centigrade. The next example. Mohit's house is at a distance of 20 meters towards the east from Rohit's house. Meena's house is 15 meters towards the west, Samir's house 25 meters towards the north, and Savita's house 5 meters towards the south from Rohit's house. Represent the distance between Mohit, Meena, Samir and Savita's houses from Rohit's house in integers. The distance between Mohit, Meena, Samir and Savita's houses from Rohit's house is given. Therefore, we represent Rohit's house as 0. In this example, we represent the distance towards the east by a positive sign and its opposite direction, that is west, by a negative sign. Therefore, the distance from Rohit's house to Mohit's house is plus 20 meters and the distance from Rohit's house to Meena's house is minus 15 meters. Similarly, we represent the distance towards the north by a positive sign and the distance towards the south by a negative sign. Therefore, the distance from Rohit's house to Samir's house is plus 25 meters. Can you find the distance from Rohit's house to Savita's house? Any ideas? Since the distance towards the south is represented by a negative sign, the distance from Rohit's house to Savita's house is minus 5 meters. Today, we have seen examples of integers. In the next video, we will see some misconceptions and common mistakes related to this. Today, we will see some misconceptions related to integers. Misconception 1. Of the following, which numbers are integers? Often, only negative numbers are mistaken as integers. In which case, you might choose option 1, which is incorrect. Similarly, it is understood that the collection of integers has positive numbers and negative numbers alone and no 0, which will lead you to choose the option 2, which is again incorrect. The correct answer is obviously option 3, since integers include all negative numbers, positive numbers, and 0. Misconception 2. Which option represents the relation between natural numbers, whole numbers, and integers? Sometimes it is difficult to find the relation between these three sets of numbers. Often, options 1 and 2 are chosen, which are incorrect. The correct understanding is that natural numbers range from 1 to infinity. Whole numbers consist of all natural numbers along with 0. This means natural numbers are included in the collection of whole numbers. Similarly, including negative numbers along with whole numbers gives a collection of integers. This means the collection of integers contains all whole numbers and all natural numbers. Therefore, option 3 is the correct answer. Today, we have seen some misconceptions related to integers.
On the picnic spot, people were playing different types of games. Some kids were singing songs, and some others were playing Catch the Thief, and many kids were just sitting on the mat and chatting with each other. Pushpa and Pankaj were playing catch with a ball. While playing, the ball slipped from Pushpa's hand and falls on a rose plant.
Oh Pushpa, check whether the plant is fine or broken.
Let's check. No, the plant is fine. Look, Pankaj, there are many flower plants here other than the rose. These are good examples of herbs and shrubs.
Right then, father comes in the scene.
Nice, Pushpa. Do you know that the rose plant is a shrub?
I also know this, Dad. We were taught yesterday only that there are 4 types of plants.
Really? Tell which are those?
Herbs, shrubs, trees, and vines. Vines are also of 2 types.
Creepers and climbers.
Dad, I was about to tell this.
Okay. Pankaj, let's do one thing. You explain some types of plants and I will explain the rest. This way, both of us can understand and remember it.
Done. I will start with the herbs. Look at these small plants which have thin and soft stems are called herbs. Coriander, mint, radish, carrot, beetroot, rice and mustard are some examples of herbs.
Very good. I will tell you something funny. Most types of herb plants are small, but the banana plant, which is also a herb, is pretty huge.
Wow, I didn't know that banana plant is also counted in herbs. Okay, now it's my turn to tell about shrubs. These plants are small to medium in size and they have thin but hard stems. The branches of these stems also originate from near the ground only. Lemon, basil, rose, and pomegranate are some other examples of shrubs.
The next type of plants are trees. Their stems are hard and thick and their branches begin from higher part of the stem. Mango, dates, coconuts, etc. are some examples of trees.
Kids, do you know that the tallest plant in the world is redwood, which can grow taller than 100 meters, which means taller than a 30-floor building. It is found in the United States of America.
What? Even the buildings of our city aren't that tall. On one hand, there are redwood trees and on other hands, we have creepers which don't even get up from the ground.
The stems of creepers are too soft, which is why they spread here and there on the earth. Watermelon, muskmelon, and pumpkin are examples of creepers.
My mouth is watering on hearing about watermelon, muskmelon and mango, etc.
Really? Does your mouth water after hearing about bitter gourd as well?
Yuck, I will let you eat that. I don't like it.
I like it. We get this nutritious fruit which is cooked like vegetables from climbers. These vines climb up the trees, ladders or other solid structures around them. Grapevine is also a climber.
If you tell me this, I will agree that you know about plants.
Okay, ask.
On which plant the largest fruit of the world grows?
Oh, I never thought about it. When we are talking about vines, it must be watermelon.
Do you know? Right. Jackfruit is the largest of all the fruits which hang on jack tree. Do you know that jackfruit can weigh up to 50 kg? Pushpa, the people who are watching this video more than you.
It was a great experience today, and I also got to know that both my kids are very bright. It's getting dark. Let's get ready to go home.
Oh, I was enjoying this so much.
Don't worry, we will visit Sundar Uncle's garden tomorrow evening.
Yes, we will visit for sure, because we still have to discuss stems, flowers and roots of plant.
Let's go, children. We're getting late.
Yes, Daddy, let's go.
Today we will learn about the exterior angle of a triangle and its properties. A triangle is a polygon with three sides, such as triangle PQR. It has three vertices, just like triangle PQR has vertices PQ and R. It has three sides, just like triangle PQR has sides PQ, QR and PR. And it has three angles, like triangle PQR has angles, angle PQR, angle QRP and angle RPQ. As you can see, all these angles are interior angles of triangle PQR. When we extend one side of the triangle, like here, side QR is extended to S, then we get an angle. Can you tell me, what can we call this angle? Think for a while. Let me tell you. Since it is an angle located in the exterior of the triangle, we will call it the exterior angle of the triangle. Here, we have extended the side QR through point S. This gives us angle PRS, which is an exterior angle of the triangle PQR. Angle PRS is an exterior angle formed at vertex R of triangle PQR. Now consider this, if we extend the side PQ through M, then which exterior angle will be formed? You got it right. We will get the exterior angle, angle RQM, which is an exterior angle formed at vertex Q of the triangle. Similarly, if we extend the side PQ through U in the upward direction, we will get the exterior angle, angle RPU. Exterior angles can be formed for a triangle in many ways. If we extend the side QR towards the left, we get an exterior angle, angle PQT, formed at the vertex Q. Now you may pause the video and try to find the exterior angle by extending the side PR. Now look at this figure. Here, angle PRS is the exterior angle of triangle PQR. We can also see that angle QRP and angle PRS are adjacent angles. In addition to the adjacent angle, angle QRP of the exterior angle PRS, the remaining two angles of triangle PQR, namely angle RPQ and angle PQR, are called the two interior opposite angles or the two remote interior angles of the exterior angle, angle PRS. The exterior angle of the triangle and its two interior opposite angles share an interesting relationship. Let's understand this in the case of triangle PQR and its exterior angle, angle PRS. Cut out or trace copies of angle RPQ and angle PQR and place them adjacent to each other at angle PRS. As you can see here, angle RPQ and angle PQR together entirely cover the angle PRS. What does this tell you? Give it a try. You got it right. This shows us that the measure of the exterior angle, angle PRS of triangle PQR is equal to the sum of its interior opposite angles, angle RPQ and angle PQR, which means angle RPQ plus angle PQR is equal to angle PRS. So, now we can say that the exterior angle of any triangle is equal to the sum of its interior opposite angles. Now take a piece of paper and draw triangle PQR and form its exterior angle, angle PRS. You can make any type of triangle. After making the triangle, find the measure of the exterior angle, angle PRS and the interior opposite angles using a protractor. Can you say that angle PRS is equal to angle RPQ plus angle PQR? Why don't you pause the video and find out? Each time, you will find that the exterior angle of a triangle is equal to the sum of its two interior opposite angles. Let's reconfirm this using a logical method. Here we are given triangle PQR where angle PRS is the exterior angle. we have to show that angle PRS is equal to angle RPQ plus angle PQR. To show this, we will draw line RM from vertex R parallel to side QP of triangle PQR. Here we can see that side QP is parallel to line segment RM and QS is a transversal. With this information, can you tell us the relation between angle PQR and angle MRS? Think for a while. Let me tell you, here QP and RM are parallel and angle PQR and angle MRS are corresponding angles formed by a transversal QS of side QP and line RM. Since the corresponding angles formed by a transversal of the parallel lines are equal, therefore we can say that angle PQR is equal to angle MRS. Similarly, here angle RPQ and angle PRM are alternate angles, and the alternate angles formed by a transversal of the parallel lines are also equal. So, angle RPQ is equal to angle PRM. If we talk about angle PRS, its measure is the sum of the measure of angle PRM and angle MRS, which we can write as angle PRS is equal to angle PRM plus angle MRS. If we replace angle PRM with angle RPQ and replace angle MRS with angle PQR, we will get angle PRS is equal to angle RPQ plus angle PQR. This verifies the fact that exterior angle of a triangle is equal to the sum of its interior opposite angles. The above relation between an exterior angle of a triangle and its two interior opposite angles is referred to as the exterior angle property of a triangle. By now you must have understood the concept properly. Today we learned about exterior angle of the triangle and its properties. In the next video, we will see some examples related to this concept. Today we will see some examples based on the exterior angles property of a triangle. Find the values of x and 2x in the given figure. Exterior angle property of a triangle tells us that the measure of an exterior angle of a triangle is equal to the sum of the measures of its interior opposite angles. Can we solve the given question based on this understanding? Think for a while. Yes, we can definitely solve this question using the exterior angle property. Here we can see that angle ABD is the exterior angle of a triangle ABC measuring 123 degrees, and the interior opposite angles to this angle are angle BAC and angle ACB. Here the measure of angle BAC is x and the measure of angle ACB is 2x. From the exterior angle property of a triangle, we can write angle ABD is equal to angle BAC plus angle ACB, which means 123 degree is equal to x plus 2x, which means 123 degree is equal to 3x. We have to find the value of x here. On this side, 3 is multiplied with x. If we bring 3 to the other side, then we will have to divide 123 by 3. When we divide 123 by 3, we get x is equal to 41. So, 2x is equal to 2 multiplied by 41 degree is equal to 82 degree, and the value of x is 41 degree and the value of 2x is 82 degree. Next example. Find the measure of angle BCD and angle BCA in the given triangle. Here, angle BCD is the exterior angle of triangle ABC, and angle CAB and angle ABC are the two interior opposite angles of angle BCD. As you know, the measure of the exterior angle of a triangle is equal to the sum of its interior opposite angles. Therefore, we can write angle BCD is equal to angle CAB plus angle ABC. Since angle CAB is equal to 80 degree and angle ABC is equal to 60 degree, so angle BCD is equal to 80 degree plus 60 degree is equal to 140 degrees. Now can you tell us how we will find the measure of angle BCA? Think for a while. We can find it using different methods. Here we can see that angle ABE is the exterior angle of triangle ABC and angle BCA and angle CAB are the two interior opposite angles of angle ABE. So, we can say that angle ABE is equal to angle BCA plus angle CAB. Or we can write it as angle BCA is equal to angle ABE minus angle CAB. Since angle ABE is equal to 120 degree and angle CAB is equal to 80 degree, therefore, angle BCA is equal to 120 degree minus 80 degree is equal to 40 degree. We can find the measure of angle BCA using another method. As you can see here, angle BCD and angle BCA form a linear pair. So, their sum will be 180 degree. Angle BCD plus angle BCA is equal to 180 degree. We can say that angle BCA is equal to 180 degree minus angle BCD is equal to 180 degree minus 140 degree is equal to 40 degree. We can also find the measure of angle BCA using angle sum property of a triangle, which we will discuss in detail soon. Always remember, in mathematics, we can find answers to any question using different methods. So today we saw some examples based on exterior angle property of a triangle. In the next video, we will see some misconceptions related to them. Today we will see some misconceptions related to the exterior angle of a triangle and its properties. Misconception 1. Can the exterior angle of a triangle be a straight angle? Some students get the wrong idea that the exterior angle of a triangle can also be a straight angle, that is an angle of 180 degree. But this is a misunderstanding. The reason being, it is not possible to make a triangle where the exterior angle measures 180 degree. Let's understand this. Suppose we draw a triangle PQR in which the angles are shown as given. If we keep reducing the length of the side PQ, then we will notice that the measure of the exterior angle PRD keeps increasing. When the points PQ and R lie in the same line, then the exterior angle will measure 180 degree. But in such a case, they will not form a triangle. From this you can understand that the exterior angle cannot be a straight angle. Hence, option 1 is wrong and option 2 is correct. Misconception 2. When the exterior angle of a triangle is a right angle, which of the following statements is correct? About each of the interior opposite angles, we note that the measure of the exterior angle of a triangle is equal to the sum of its interior opposite angles. Some students believe that if the exterior angle of a triangle is a right angle, then the interior opposite angles will be equal. That is, they will always measure 45 degree. But this is a wrong understanding because the measure of the interior opposite angles of a triangle can be different from 45 degree. For instance, it can be 30 degree and 60 degree or 20 degree and 70 degree, etc. Hence, option 1 is incorrect. Some students also believe that When the exterior angle of a triangle is a right angle, then one of the interior opposite angles is an acute angle and the other an obtuse angle. But this is not possible. Therefore, option 2 is also an incorrect answer. An acute angle measures less than 90 degree and an obtuse angle measures greater than 90 degree. If we add them, then the total measure will be more than 90 degree. Which means when the exterior angle of a triangle is a right angle, then the interior opposite angles cannot have one acute and one obtuse angle. The correct understanding is that the measure of the exterior angle of a triangle is equal to the sum of its interior opposite angles. Therefore, when the exterior angle is a right angle, that is an angle of 90 degree, then the sum of its interior opposite angles should also be 90 degree. This is possible only when the two interior opposite angles of the exterior angles are acute angles. Therefore, the correct answer to the given question is option 3. Misconception 3. Is the exterior angle of a triangle always an obtuse angle? From the examples, students often misjudge the exterior angle to be an obtuse angle. This makes them believe that the exterior angle is always an obtuse angle. But this is a misunderstanding. Look at the given triangles. What do you understand by looking at the exterior angle? Think for a while. You got it right. From this, you will observe that the exterior angle of a triangle can not only be an obtuse angle, but it can also be a right angle or an acute angle. Hence, option 1 is the wrong answer and option 2 is the correct answer. So today we saw misconceptions related to the exterior angle of a triangle and its properties. Finding the value of an expression when the value of one variable is given. Today we will learn to solve an algebraic expression when value of one variable is given. You have already learned about algebraic expressions. Now, let's understand it better with the help of an example. Komal's mother's age is 7 more than twice her age. If Komal's age is k years, then provide a suitable expression to calculate her mother's age. As we know, Komal's age is k years and Komal's mother's age equals 7 more than twice Komal's age, which is 2 multiplied by k plus 7 is equal to 2k plus 7. Therefore, the expression to find her mother's age will be 2k plus 7. Now let us learn how to solve an expression if value of one variable is given. Let's solve a question to understand this. Find the value of the expression x square plus 3x minus 14. If x is equal to 3, we substitute x is equal to 3 in the given equation. On doing so, x square becomes 3 square and 3x becomes 3 multiplied by 3. Now our expression becomes 3 square plus 3 multiplied by 3 minus 14. 3 square is 3 multiplied by 3, 9. And 3 multiplied by 3 is 9. Substituting these values in the equation, we get is equal to 9 plus 9 minus 14. 9 plus 9 is 18. And 18 minus 14 is 4. Therefore, the answer will be 4. Example 2. Simplify the following expression and find its value when the value of a is 5. A square minus 3, a plus 2. Simplifying this expression, we get a square minus 3a minus 6. Substituting a is equal to 5 in this expression, we get 5 square minus 3 multiplied by 5 minus 6 is equal to 25 minus 15 minus 6 is equal to 25 minus 21 is equal to 4. The solution to this is 4. Today we learned to solve an algebraic expression when value of one variable is given. In the next video, we will understand it better with some more examples. Thank you. Finding the value of an expression when value of one variable is given. Examples. Today we will learn examples on solving an algebraic expression when value of one variable is given. In the previous video, we learned about solving algebraic expressions when the value of one variable is given. Let's understand this better with the help of some examples. Example 1. Sumit has y number of roses and his brother Amit has 5 more than twice the number of roses Sumit has. If y is equal to 2, then find the total number of roses. As we know, the number of roses Sumit has is y, and his brother Amit has 5 more than twice the number of roses than Sumit. Therefore, the total number of roses with Amit will be is equal to 2 multiplied by y plus 5 is equal to 2y plus 5. The total number of roses will be is equal to y plus 2y plus 5 is equal to y plus 2y plus 5. By simplifying this expression, we get is equal to 3y plus 5. As we know that the value of y is 2, by substituting y with 2, we get is equal to 3 multiplied by 2 plus 5 is equal to 6 plus 5 is equal to 11. Hence, the total number of roses will be 11. Example 2. Simplify the following expression and find its value when the value of x is minus 3. 4. X plus 1 plus 2x minus 2. By simplifying this expression, we get 4x plus 4 plus 2x minus 2. By rearranging similar terms, we get 4x plus 2x plus 4 minus 2. By solving similar terms, we get 6x plus 2. Substituting x is equal to minus 3 in the expression, we get is equal to 6 minus 3 plus 2 is equal to minus 18 plus 2 is equal to minus 16. Therefore, our answer will be minus 16. Example 3. In the given expression, the value of x is 3. Find the value of the expression x cube plus 2x square plus 5. Substituting x is equal to 3 in the expression, we get 3 cube plus 2, 3 square plus 5. Here, 3 cube is 3 multiplied by 3 multiplied by 3 is equal to 27, and 2 multiplied by 3 square becomes 2 multiplied by 3 multiplied by 3 is equal to 18. Therefore, 27 plus 18 plus 5 is equal to 50. So today we saw examples on solving an algebraic expression when value of one variable is given. In the next video, we will see some misconceptions related to this. Thank you.
Objectives: to understand how plants reproduce.
Got hold of you. Sham, if you keep hiding in the same place, then it will be easy for us to find you, right?
These red roses smell so nice.
Look, Ramu Kaka has cut a part of the stem of the rose plant and he has put it in the soil. Why is he doing something like that?
Come, let us ask Ramu Kaka.
Hello Ramu Kaka, we just saw that you cut a part of the stem of the rose plant and planted it in the back in the soil. We could not understand as to why you did that.
Children, I cut a part of the rose plant stem and planted it in the soil. In a few days, roots will emerge and it will become a new plant.
Oh, so plants reproduce in such ways too. I want to know more about this. I shall ask grandfather. He has a lot of interest in gardening.
This means that in plants like roses, it is a method of reproduction.
Look, when I saw this pond last week, the moss was only on some area. But today, the whole pond is green.
This is algae. Remember, we read in the first chapter in science that algae grow in the presence of water and nutrients. But how do we find out that how does algae spread so fast?
Don't be worried, children. Let me tell you, I have been seeing this pond for a number of years. Friends, algae get divided into 2 or more parts. These divided parts or subparts become a different creature. And with this continuous growth, the algae spreads over a large area.
There are a lot of secrets hidden in nature. It is astonishing to know that the algae reproduce through the means of division.
Look, this is the mango plant.
This is such a little plant. Sham, you must take care of this plant.
Children, come inside. Come and eat something. Sham, there are some apples lying near the basket of potatoes. Please bring them. I shall cut them and give them to you.
Yes, Mom, sure. What is this green and white color growth on the potatoes? Let me show it to Rani and Ram. Look, what is this on these potatoes? It looks they have gone bad.
I have seen this a few times earlier. When the potatoes become old, we can see such growth on them. My mother told me that this is known as the eye of the potato.
Eye of the potato? Since when did potatoes have eye?
Yes, children. Rani's mother was right. This is known as the eye of the potato. Why don't all of you conduct an experiment? You will understand better like that.
What kind of an experiment, Mother?
Cut this potato into 2 halves. Take them and sow them in the soil outside. Water it every day and then see what happens in a few days.
Friends, shall we do as Mother said?
Yes, sure. There we are. Done. Now we will have to come and water this every day and come to your house every day.
Children, Rani, Sham and Ram looked every day at the place where they had planted the potato. After a few weeks, there was tiny little plant over there.
Rani, Ram, see. Didn't I say that I saw a few leaves growing? Look.
Yes, you are right. A plant of potato emerged when we sowed a potato.
This is like the rose plant we saw, isn't it?
Children, there are a few eye-like structures on me. After a few weeks, these grow into new plants.
Besides potato, onion, ginger and turmeric also reproduce asexually through vegetative propagation.
I completely forgot in this conversation that Mother had asked me to bring bread from the market.
I shall also come with you, Rani. Now soon we will eat mangoes and potatoes from Shyam's own field.
Look, Ram, this bread has fungus on it. Take through this. You know, Ram, whenever we buy bread, we must be watchful of fungus.
But how did this fungus come on the bread? Come, first let us go and give a mother a bread.
And then we shall look for answer to your question.
Isn't it so interesting, friends, that it is possible for some plants to reproduce without a flower or seed? Plants of rose and potato through vegetative propagation, algae through budding and fungus through fragmentation. I want to know more about reproduction in plants. Now, we shall learn about this in the next video.
That is known as the stamen, and the female reproductive part is known as the pistil.
Look at Raja and Vijay, how they are running after the butterflies.
Where there are so many flowers, it is obvious to have a lot of butterflies and honeybees.
Yes, because they get to suck the nectar of so many flowers.
Remember, we had studied about the interdependence in the first chapter of science.
Yes, the honeybees suck nectar from the flowers and in return help pollinating the flowers. Yes, friends, we honeybees and butterflies really like the nectar of the flowers. The male part of this plant, stamen, has a stigma where the pollen grains are found. When other insects or I sit on the flowers, the pollen grains get stuck to our body. Then when we sit on some other flower, the pollen grains fall on them. In this way, the pollen grains are transported from the anther to the stigma. Sometimes the pollen grains fall on the same flower stigma. This is known as self-pollination. Other times the pollen grains fall on the stigma of some other flower. This is known as cross-pollination.
Look at this flower. This is the stigma. Look, there is a bud-like structure here. What is this?
Yes, even this flower has a part like this.
I remember seeing something similar in the science book too.
Why don't we ask the teacher about it?
Why don't we draw these flowers in our drawing books and label them? Friends, why don't you also make a picture of a flower and label it? Till then, I shall suck some nectar from some flowers.
Children, now all of you come here. So, how was the observation?
Look, teacher, I have made this drawing and labeled it.
Teacher, I picked up a few flowers. I noticed a bulb-like part in most of them. Look, can you please tell us what it is?
Yes, sure, Meena. Come, let us all look at this flower. Look, this is the anther and this is the stigma. This here is the ovary. When the pollen reaches the stigma, they track structure to the ovary. Here, the fertilization takes place. The ovary becomes the fruit and the other parts of the flower withers and falls off.
It is very interesting. I used to think that the role of the flower is only to provide a good smell.
But it is because of the smell of the flowers that the honeybees and butterflies are attracted towards them.
What is this on your shirt, Shyam?
Looks like some flowers or dried seeds.
Does this mean you are also helping in pollination?
Did all of you observe these things which have got stuck to Shyam's shirt?
So friends, the flowers are very important for all of us. Actually, if there are no flowers, there would be no seeds, no plants at all. My friends and I help in pollination. Have you ever thought what would happen if we did not pollinate? Now we shall meet in the next video.
Square root of a number, examples of division method. Hello friends, welcome to this video. In the previous video, we learned to find the square root of a perfect square number by the division method and to calculate the number of digits in its square root. In this video, we will see some examples associated with the division method of finding the square root. Let's look at the first example. There are 961 chairs in the hall. They are to be arranged in such a way that each row should have as many chairs as the total number of rows. So can you guess how many rows will be made in this way? Here, we have to arrange 961 chairs in such a way that each row has as many chairs as the total number of rows. But this would be possible only if the total number of chairs we have been given here is a perfect square number. If it is a perfect square, then its square root gives us rows and chairs in each row. Let us find the square root of 961 using the division method. First of all, we will draw lines like this around the number 961 and then put bars on it. The number of digits in this number is odd, so there will be only one digit below the leftmost bar. Now, we will find a number whose square is equal to or smaller than 9. That is, the number below the leftmost bar. Here that number is 3. 3 is the divisor of this number and also the first digit of the quotient. Write 9 below the first number and subtract both. Here we are getting 0. We will write the number below the next bar next to the received remainder. Now leave a blank space for the units place of the new divisor and multiply the digit in the units place of the first divisor by 2. After this, write the resulting product beside the blank in this way. To fill this blank, we will find the largest digit that will be the new digit of the quotient and multiply the new divisor by this new digit of the quotient. The product will be either less than or equal to the factor. The digit 1 will be put in the blank space because 61 times 1 is equal to 61, which is equal to the new factor. Thus, the remainder will be 0. Now there are no digits left in the given number. Thus, we are getting 31 as square root of 961. So, the hall will have a total of 31 rows of chairs and each row will have 31 chairs. Let us now see another example. Find the smallest natural number which, if added to 1000, gives us a perfect square number. If you want, you can pause the video here and solve the question. The number 1000 is not a perfect square number. Can you guess why? This is because the number of zeros at the end of this number is odd, and we know that the number of zeros at the end of any perfect square number is always even. To solve this question, let us first find the square root of the number 1000 using the division method. We can see here that we have got 39 as the remainder. The remainder here is not a zero, so 1000 will not be a perfect square number. That is, here the quotient is 31. This shows that the square of 31 is smaller than 1000. Because the number 32 is larger than the number 31, so the square of the number 32 will also be larger than 31. The square of 32 is 1024. This means the square of the next whole number 32 will be larger than 1000. So, by adding the number 24 to 1000, we will get a perfect square number 1024. In this video, we saw some examples associated with the division method of finding the square root. In the next video, we will see some common mistakes associated with them. Thank you. Square root of a number. Common mistakes related to division method. Friends, welcome to this video. In the previous video, we saw examples of finding the square root using the division method. In this video, we will see some common mistakes associated with it. A teacher asked his students to find out the square root of the number 15,625 using the division method. 3 students, Ravi, Amit and Vishal, completed the first step, that is, placing the bar on the digits of the perfect square number. The response of the 3 students are given below. Can you tell which of these is correct? If you want, you can solve the question by stopping the video here. Many children accept Amit's answer as correct. They place bars by pairing digits from left to right. But this is wrong. The correct method is that in order to make a pair of whole numbers, we always have to start from the units place, that is, from the right side, and then pair them with the digits on the left side. In the second option, Ravi started right. He started from the units place, that is, from the right, and then moved the bar to the left. But he has made a triplet of numbers here, which is wrong. Because we have to make only pairs of numbers. The correct method is that while pairing the digits in the square root of any perfect square number, we have to place the bar by pairing from the units place, that is from the right side. Because the number of digits here is odd, there is only one number below the leftmost bar. Hence, option C of Vishal is correct. Now all the students, after doing the first step correctly, start to find the square root of the given number by the division method. This number has 5 digits and is paired 3 times, so it will have 3 digits in its square root. If the number below the first bar is 1, we will take the first number because the square of 1 is the same and is equal to the number below the bar. Now we will write the number 56 below. After this, Ravi and Amit came to the conclusion that this number is not a perfect square number, but Vishal got its square root as 125. Ravi solved it this way. In the end, he got 25 as a remainder. This process is incorrect because when the second division was done here, the number 1, which was the first divisor, was not multiplied by 2 and the new divisor was not written. Now we will look at Amit's answer. Amit multiplied the whole number of the first divisor by 2 to make the new divisor, which is incorrect because we only have to multiply the digit in the units place of the first denominator by 2 and not the whole number. Vishal's solution is correct. Vishal found the square root of the number 15,625 in this way. This is the correct method. So in today's video, we saw some common mistakes associated with pairing digits in the square root. Thank you. Finding square root of a number by prime factorization. Hello friends, in this video, we will learn to find the square root using the prime factorization method. Friends, there are some perfect squares on the screen. Can you find the square roots of these numbers? If the square of 4 is 16, then we can say that the square root of 16 is 4. Similarly, the square of 5 is 25. So we can say that the square root of 25 is 5. So tell me, if the square of 7 is 49, then what will be the square root of 49? Absolutely right. The square root of 49 will be 7. Similarly, can you find the square root of the number 729? It is not essential that we must always remember the square root of all perfect squares. This is because we can find the square root of any number using different methods. So, let us find the square root of 729 using the prime factorization method. As per the name of this method, we can guess that we have to do the prime factorization of the number. In this method, we divide the number by prime numbers until we get a prime number or 1. For this, we will draw a figure similar to the one on the screen. In the second column of the top row, we will write the number that we wish to factorize. Now, let's get started. Find the smallest prime number that divides 729 completely. That is 3. Write 3 in the first column of the first line. Dividing 729 by 3 gives us 243. Write it below 729. Now find the smallest prime number that divides 243 completely. That is 3. Write 3 in the first column of the second line. Dividing 243 by 3 gives 81. Write it below 243. Now, find the smallest prime number that divides 81 completely. That is 3. Write 3 in the first column of the third line. Dividing 81 by 3 gives the result 27. Write it below 81. 27 is not a prime number. 3 is the prime factor of 27. Write it in its designated place. Dividing 27 by 3 gives us 9. Write 9 under 27. We know that the square of 3 is equal to 9. So, we will write 3 in the first column of the fifth row and also under 9. Now, we get the number 3 in the last row of the second column, which is a prime number which has only 2 factors, the numbers 1 and 3, which we mark like this. All the prime factors of the number 729 are written in the first column. And number 1 is the remainder in the last row of the second column, indicating that the process is over. We can write the number 729 as the product of its prime factors. Now we will see how many prime numbers are in pairs in this factorization. There are 3 pairs of number 3. By the laws of exponents, we can write this multiplication of factors as we get 729 as the square of 27. That is, we can say that the square root of 729 is 27. Thus, here we get the square root of the number 729. Is 432 a perfect square? If you think it is a perfect square, then find its square root using the prime factorization method, and if not, find the number which can be used to divide 432 such that we get a perfect square. You can pause the video here and factorize this number. We know that if a number is a perfect square, it is equal to the square of its square root. Now let us depict the number 432 as a product of its prime factors. We can see that not all prime factors of this number are in pairs here. That is, it is not a perfect square. There is no pair of 3 here. So, if we divide the number 432 by 3, we will get the number 144, which is a perfect square. Its square root is 12. So, we learned to find the square root by the prime factorization method and have seen examples related to it. See you in the next video with some more examples related to it. Thank you. finding square root of a number by prime factorization, illustrative examples. Hello friends! In this video, we will see some examples of finding the square root by the prime factorization method. Find the square root of the number 3969 using the prime factorization method. In the prime factorization method, we will first do the prime factorization of the number 3969. And we will know all its prime factors this way. Now we will express the number 3969 as the product of its prime factors. After this, we will group the prime factors into pairs in this way. Then, we will take one factor out of each pair and multiply them. This product is the square root of that number. That is, the number 63 is the square root of the number 3969. Let us see another example. Find the smallest perfect square which is completely divisible by 2, 16 and 19. If we had to find only a number that was divisible by these three numbers, then we would have to find the LCM of these three numbers. Thus, we would have received the number 304. The number 304 is not a perfect square, but here we need a perfect square. We know that all prime factors in the perfect square come in pairs. In prime factorization of the number 304, only number 19 is not in a pair. If we multiply both sides by 19, we get the number 5776 on the left-hand side, which is a perfect square. We can also see its prime factors on the right-hand side, where we will find all its prime factors in pairs. Therefore, the number 5776 is the smallest perfect square which is divisible by 2, 16 and 19. We can also see that the square root of the number 5776 is 76. In this video, we have seen some examples of finding the square root using the prime factorization method. Hope you have understood this method very well. Thank you. Square root of decimal. Hello friends, welcome to this video. In this video, we will find the square root of a decimal number. Let's see what Vishal is doing. Vishal's ball is stuck on the roof. To bring it back, he has put a ladder against the wall in this way. The height of the roof is 5.5 meters and the length of the ladder is 7.3 meters. Can you tell how far Vishal has placed the ladder from the wall? If we look at the figure carefully, we will see that a right triangle is being formed here. Let's name it triangle ABC. Here, AB is the height of the roof, angle B is the right angle, and AC is the hypotenuse of this triangle. Here we have to find the length of BC, which is the base of this triangle. Suppose its value is x. How do we find the value of x? According to the Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of the base and the perpendicular. For the right angle triangle ABC, we can also write it like this. Substituting the value of all the sides, we get x square is equal to 23.04. But we have to find the value of x. For this, we have to find the square root of the number 23.04. We will be doing this using the division method. Here we will write the divisor. Here, the dividend and the quotient will be written here. The quotient obtained by this method will be the square root of this number. First of all, we will place a bar on the number 23.04. There are two parts here. One part has a whole number and the other has a decimal number. In these two parts, we will place the bars in different ways. Starting from the units place in whole number, we pair the digits on the left side and place a bar on them. Here, we will place a single bar on 23. To place a bar on a decimal number, we start with the decimal and place a bar on the digits on the right side. If a number has an odd number of digits after the decimal, then at the end we pair it by writing 0 next to the remaining digit. For example, if there was one more digit at the end of this number, we would make a pair by putting a 0 next to it. Note that adding the 0 after the last non-zero digit of the decimal number does not change the value of the number. After placing the bar here, the next step will be to find the largest natural number whose square is equal to or smaller than the number below the leftmost bar. That is, the number whose square is equal to or smaller than 23. The square of 4 is 16, which is smaller than 23, and the square of 5 is 25, which is larger than 23. Therefore, we will choose the number 4. The number 4 obtained is our divisor and also the first digit of the square root of this number, which we will write in the quotient. Considering the number below the leftmost bar as 23 and writing 16 below it, we will find the remainder. The remainder obtained here is 7. All the whole numbers in our original number are done. Only decimal numbers remain. So now, we will add the decimal to the quotient. Then, we will write the number of the next pair after the remainder. That number here is 04. And thus, our next composite number is 704. Now for the new divisor, multiply the unit digit of first divisor by 2. We will write the resulting number here, leaving a blank space to the right. Now, to fill in the blank, we will think of the largest possible digit, which will be the first digit after the decimal in the quotient, and when the new divisor is multiplied by the same new digit, the product obtained will be less than or equal to the dividend. So, our new digit here will be 8. We will write 8 after the decimal in the quotient. After this, 704 will be written under the new number to be divided. Then, we will subtract them. Here, the remainder is 0 and no digit is left from the original number. So, the square root of the number 23.04 will be 4.8. Note here that we have to keep repeating this process until all the digits of the original number have been divided. If the remainder becomes 0 at the end, the quotient will be equal to the square root of this given number. But if the remainder of a number does not come to 0, then the process will have to be done by adding another pair of zeros at the end of this number or guessing the square root of this number. This gives us the value of x as 4.8. This means that Vishal has placed the ladder at a distance of 4.8 meters from the wall to climb the roof. So in this video, we learned to find the square root of a decimal number. In the next video, we will see examples of this. Thank you.
Sanya, a 13-year-old curious city girl who studies in class 8. Mummy, Sanya's mother, who facilitates them in understanding different concepts. Kabir, Sanya's 14-year-old brother, who helps Sanya contemplate things and perform various activities. In Sanya's house, there is a room on the roof in which the junk of the house is stored. Sanya uses this room for conducting her experiments. Sanya notices that the door of that room is broken.
Mummy, look! The door to this room is broken. Anyone can now easily open the door and enter the room.
Oh no, that is a big problem. We have already had so many additional expenses this month. The cost of a new door is the last thing that we would want to bear.
Can't we try to repair it, Mummy? We can surely look around the junk in this room and find something that can be used for repairing this.
Let's see. We can block this broken door with something like
something like a heavy iron or aluminium sheet. That way the door would remain in place, and if anyone tries to remove the sheet, we would get to know from the sound made because of the sheet's movement. Friends, do you agree with me? Can you guess what this characteristics of metals is called?
Idea is good, Sanya, but we don't have iron sheets in the house.
What you are saying is true, Bhaiya, but I had read in my science textbook that iron is malleable and can be hammered to create sheets. Any blacksmith can do this.
Yes, that sounds good, Sanya. Why don't you come with me to the market? Let us get this work done. After some time, now that we have the metal sheet ready, let us fix this to the door using a screwdriver. Oh ho! The tip of the screwdriver is not sharp. This will not help.
Mummy, can we not sharpen its tip? This is also made of metal, right?
Yes, Sanya. Let me bring a hammer from the toolbox. We can use that to fix this screwdriver.
Friends, look what I got from the toolbox. A tester. At times when an electrical appliance is not switching on despite being plugged in, Mummy uses this to test if there is any electrical current in the socket. If there is current passing through in the socket, the small bulb inside this tester lights up. Hey, wait! Let me test your understanding. Can you tell me what we call this property of metals?
Sanya, do you know utilizing this property, wires are made using metals?
Wires? Making of wires also involves utilizing a property of metals?
Yes, wires are made utilizing the tensile property of metals.
Oh, okay.
Okay, tell me, you have seen wires, haven't you? Can you tell me why there is a rubber-like coating outside the wires?
I guess so that we don't get hurt when the current passes through the wires. This rubber stops the electrical current from entering our body. Am I right, Mummy?
Absolutely, Sanya.
I guess metals have lots of properties. That is why you can make so many things using them.
Can you tell me another property of metals? Okay. Have you ever noticed how when I cook and I hold the hot metal pan using a cloth or a rubber handle? Why do you think I do that?
That's because when we make food in utensils of aluminium and steel, they get hot and holding them with bare fingers can burn our fingers. I guess metals are heat conductors, but the cloth, plastic or rubber stops heat from reaching us. Am I right?
Do you know, Sanya, we can differentiate between metals and non-metals using these properties.
I remember reading that non-metals don't have the properties that metals have. Friends, can you tell me the names of some non-metals? Bhaiya, don't you think we should have used a copper sheet for the door instead of an iron sheet? Iron can rust off.
Come here, both of you. Let me show you something.
Mummy, what is this green color over this utensil surface? Is this rust?
No, Sanya, this is not rust. However, rust forms in a similar manner as this green layer. The difference is that when iron mixes with moisture, rust is formed on the surface of iron, and when copper mixes with oxygen, this green layer is formed on the surface of copper.
Oh, so you mean all metals and non-metals undergo some chemical reactions when they come in contact with moisture and oxygen, isn't it?
You know, Sanya, there is one metal that reacts very quickly when it comes in contact with oxygen or moisture. It is therefore always stored in kerosene. Can you find out its name?
Friends, I would need your help in finding the name of this metal. Can you research and tell me this metal's name? Bhaiya, when I was in the chemistry lab in school last week, I saw that phosphorus was kept dipped in water. Now, considering that phosphorus is a non-metal, does this mean that non-metals do not react with water?
Well, that's a good question. And I think you should try and find the answer to that using your textbook.
Friends, let us look into our textbooks and see what is it that non-metals react most to.
Sanya, do you know the uses of metals and non-metals?
Oh yes, metals can be used to make machines, motor cars, trains, utensils and many more things. Nowadays, anywhere we look around, we can see things made out of metals. On the other hand, oxygen is the most important non-metal that we can think of. We all know we cannot survive without it. You know, I had read on the tube of my toothpaste that it contains phosphorus. Can you research and find out the use of phosphorus in toothpastes? Today we learned the following. 1. Physical properties of metals and non-metals. Malleability or ability to get hammered. Tensile, sound production, conduction of electricity and heat. Chemical properties of metals and non-metals. Reaction with air, water and acid. Objects made using metals and non-metals. Thank you.
Today we will see some interesting examples related to histogram. Vinita had to know how many people are literate in her village. To find out, Vinita conducted a survey in the village. The information obtained from the survey was presented by Vinita in the frequency distribution table shown below. Can you represent this information as a histogram? In the given table, the width of all class intervals is not the same. Here, we have to make suitable changes in the lengths so that the area of rectangles is proportional to the frequency of the class interval. For this, we will first find the width of each class interval and choose the lowest class width. That is, here we will choose 10. Now, we will change the lengths of the rectangles in such a way that class width is proportional to 10. For this, we will divide the frequency of each class interval by its class width and multiply it by the minimum class width of 10. Thus, the length of the rectangle for the age group 10 to 20 will be 360 divided by 10 multiplied by 10 is equal to 360. Since the class width of the class interval 10 to 20 is already 10, therefore, there was no change in the length of its rectangle. Similarly, we will find the length of rectangles for all age group. Now, we will show the age groups on the x-axis and the number of literate people on the y-axis. For this, we will take 1 unit is equal to 10 years on the x-axis and 1 unit is equal to 40 persons on the y-axis. Since we are starting with 10 on the x-axis, we will thus make a kink symbol indicating that we are not showing numbers from 0 to 10. Now, we will draw the rectangle by keeping the width of the rectangle 10 and the length of the rectangle 360 for the age group 10 to 20. Similarly, we will draw the rectangle by taking suitable width and length for all age groups. In this way, we will complete the histogram. Thus, we have represented the information given as a histogram. Next example, Shruti is a reporter. To publish the news in the newspaper, Shruti studied the change in the price of 14.2 kg of liquefied petroleum gas, that is LPG, from the year 2006 to 2012. The information received was thus represented as a histogram and printed in the newspaper. Now, read this histogram and answer the questions below. The histogram shown here shows the change in the price of LPG over different years, in which the x-axis represent years and y-axis represent price of LPG per 14.2 kg. Here, the width of each class interval is the same, that is 1 year, and the scale of y-axis in 1 unit is equal to 100 rupees. Look at the histogram and find out for how many years the price of liquefied petroleum gas, that is LPG, is less than 500 rupees. Here, we see that price of liquefied petroleum gas is less than 500 rupees in the year intervals 2006 to 2007, 2007 to 2008, 2008 to 2009. Here, the width of each class is 1 year. Therefore, we can say that the price of LPG has been less than 500 rupees for 3 years. Can you tell what is the percentage increase in LPG price in the year 2008 as compared to year 2007? Here, the price of LPG in 2008 is 420 and in 2007 the price of LPG is 340. In this way, the price of LPG increased from rupees 420 minus rupees 340 is equal to rupees 80 from the year 2007 to 2008. This increase has been made at 340 rupees, so we will consider 340 as the base. In this way, the price of LPG has increased by 23.53%. Look at the histogram and find out how many years price of LPG ranged from 500 rupees to 800 rupees. in the year 2009-2010, in the year 2010-2011, class intervals, the price of LPG is between 500 and 800. So, we can say that in 2 years, the price of LPG ranged from 500 rupees to 800 rupees. Now, pause the video and try to make a histogram with this information. Today, we have seen some interesting examples related to histogram. In the next video, we will see some misconceptions related to them. Today we will see misconceptions related to histogram. Some students think that a bar graph and a histogram are the same. If they are asked to represent some information in a histogram, they make a bar graph. It is a misconception to think that bar graphs and histograms are same. Let's understand this. The data shown here in this table show the number of readers of different age groups visiting the library of Rahul's village in March. Rohan represented this information as a bar graph and Sohan represented this information as a histogram. Can you find the difference between two by looking at them? Think. Let me tell you, the same figures are represented differently in bar graphs and histogram. Both types of representations are correct in their respective places, but differences can be seen between the two. For example, in a bar graph, the length of bars is proportional to the frequency of observation. That is, the frequency of observations is represented as the length of bars, where the area of rectangles in the histogram is proportional to the frequency of the class intervals. That is, the frequencies are represented as the area of rectangle and not the length of the rectangle. Similarly, the bars in the bar graphs are of the same width, while it is not necessary in the histogram. If the class intervals are of the same width, then the rectangles are the same width, but if the class intervals are not of the same width, then the rectangles are also not of the same width. Histograms are created for continuous group frequency distribution, so there is no gap between rectangles. Bar graphs are drawn to compare different categories, while histograms are drawn to understand the distribution of data. For example, in this bar graph, all three age groups are taken as one category. Readers of different age groups can be compared. Like here, most readers are between 20 to 40 years of age. If we look in the histogram, we find the distribution of the number of readers in the age of 10 to 40. Today we have seen the misconception related to histogram.
Hello friends, welcome to this video on triangles. Today we will discuss the inequalities in a triangle. So far we have learnt about the congruence of triangles and the properties of a triangle. Now we will see what relation is established between unequal sides or angles of a triangle. Friends, let's start with an activity. we will construct a triangle by taking thin pieces of wood of 2 cm, 3 cm and 6 cm, where the base is the 6 cm piece of wood and the remaining 2 sides are 2 and 3 cm respectively. Can such a triangle be formed? You can see that this is not possible. Now let's do one thing. If we add the 2 wooden sticks of length 2 cm and 3 cm, they will have a full length of 5 cm, which is less than the base or the third side with a length of 6 cm. And that is why it is impossible to construct a triangle with these lengths. The construction of a triangle is possible only if the sum of the lengths of any 2 sides of a triangle is greater than the length of the third side. And this is the theorem which says that the sum of any 2 sides of a triangle is greater than the third side. Therefore, we can say for triangle PQR that the sum of sides PQ and QR is greater than side PR. The sum of sides PQ and PR is greater than side QR. And the sum of sides QR and PR is greater than side PQ. Friends, we know that there are different types of triangles like equilateral triangle, isosceles triangle and scalene triangle. We know that in an equilateral triangle, all 3 sides and angles are equal. In an isosceles triangle, 2 angles and their opposite sides are equal. And in a scalene triangle, the measure of the 3 angles and the length of the 3 sides are unequal. Friends, the measurement of the angles of triangles depends on the lengths of the opposite sides. Look at triangle PQR and tell which is the longest side and the greatest angle. Here, let us increase side RP a little more to the point P' and let's connect Q to P'. Now you can see that as we increase the length of side RP, it also increased the measurement of angle Q, and now here RP' is the longest side and angle Q is the greatest angle. There are 2 theorems based on this concept. In any triangle, the side opposite to the greatest angle is longer. If 2 sides of a triangle are unequal, then the angle opposite to the longer side is greater. Friends, that's all in this session. Today we discussed the inequalities in a triangle. See you in the next video. Thank you. Hello friends, welcome to this video on triangles. In the previous video, we discussed inequalities in a triangle. Today, we will solve some questions based on the same. So let's start with the first question. Of the given options, which option is appropriate for the construction of triangle ABC? How to solve this type of question? We know that for the construction of a triangle, the sum of its any 2 sides must be greater than the third side. So, we have to check whether the given options agree with this rule or not. Let's take the first option. The sum of side AB and side BC is greater than side AC. Similarly, the sum of side BC and side AC is greater than side AB. And the sum of side AC and side AB is greater than side BC. Therefore, triangle ABC can be constructed from these sides. Therefore, according to the question, this option is correct. Similarly, in the second option, the sum of side AB and side BC is greater than side AC. And since the length of all 3 sides are equal, therefore, we will get all 3 inequalities like this. And thus triangle ABC can be formed from these sides. Therefore, according to the question, This option is also correct. Now let's move to the last option. Here also we will repeat the same process. You can pause the video and try to solve it yourself. Here, the sum of side AC and side AB is equal to side BC. Therefore, triangle ABC cannot be formed from these sides. So, according to the question, this option is incorrect. Now let's take the next question. Prove the following statements in quadrilateral PQRS. First of all, we will construct a quadrilateral and name it PQRS. Now, we will join the diagonals QS and PR. We will solve the first question. We have to prove that PQ plus QR plus RS plus SP is greater than QS plus PR. In a triangle, the sum of two sides is greater than the third side. So, in triangle PQR, we can say that the sum of side PQ and side QR is greater than side PR. Similarly, in triangle QRS, the sum of side QR and side RS is greater than side QS. In triangle RSP, the sum of side RS and side SP is greater than side PR. In triangle SPQ, the sum of side SP and side PQ is greater than side QS. Now, if we add all four inequalities, then we will get. Now, by simplification of the left side and the right side, you will get. And thus we proved that the sum of the four sides of a quadrilateral PQRS is larger than the sum of its diagonals. Let's move to the second question. Here we have to prove. First, we will name the intersection of the diagonals as O. Friends, if we pay attention here, we have four small triangles. Triangle POQ, triangle QOR, triangle ROS and triangle SOP. We know that the sum of any two sides of a triangle is greater than the third side. Hence, in triangle POQ, the sum of side PO and side OQ is greater than side PQ. Similarly, in triangle QOR, the sum of side QO and side OR is greater than side QR. In triangle ROS, the sum of side RO and side OS is greater than side RS. In triangle SOP, the sum of side SO and side OP is greater than side SP. Now if we add all four inequalities, then we get. By simplifying it, we will get. If you write it this way, it will be something like PQ plus QR plus RS plus SP is smaller than 2 PR plus QS. And thus, it has also been proved. So friends, that's all in this session. Today we solved some questions based on inequalities in a triangle. In the next session, we will discuss some facts related to this topic. Thank you. Hello friends, welcome to this video on triangles. In the previous video, we solved some questions based on the inequalities in a triangle. Today, we will discuss some facts related to the same. So let's start. With reference to triangle ABC of the given options, which option is correct? In the first option, if the sum of AB and BC is equal to AC, it will form a line and not a triangle. This means that this option is incorrect. According to the second option, angle B is greater than angle C. So the side opposite to angle B will be greater than the side opposite to angle C. That is, side AC will be greater than side AB, or in other words, side AB will be smaller than side AC. This means that this option is also incorrect. Now let's move to the next option. Here, side BC is smaller than side AC. That is, the angle opposite to side BC will be smaller than the angle opposite to the side AC. Which means angle A will be smaller than angle B. Or in other words, angle B will be greater than angle A. Therefore, this option is correct. Now let's take the last option. Side BC is smaller than the sum of side AB and side AC. These are the three sides of the triangle ABC, and the size of any one side of a triangle is smaller than the sum of the other two sides. So, this option is also correct. Let's take the next question. In triangle ABC and triangle PQR, angle A is equal to angle P. So, the opposite side, side BC of angle A, will be equal to the opposite side, side QR of angle P. Is this statement true? You can also pause the video to answer this question. Friends, triangle ABC and triangle PQR are two different triangles. Just because their angles are equal, it doesn't mean the length of their sides of these triangles will also be equal. Friends, if you look at these triangles, then the measurement of both angle A and angle P is 90 degrees. But the length of their opposite sides, side BC and side QR, are not equal to each other. Therefore, this statement is false. This type of concept is true for only one triangle and not in case of two different triangles. Friends, with this, we will end this video. Today we discussed some facts related to inequalities in a triangle. See you in the next video. Thank you.
Today we will learn about the kingdom Plantae and the subclasses of this kingdom, Thallophyta, Bryophyta and Pteridophyta. Let us first discuss the kingdom Plantae. Kingdom Plantae consists of all autotrophs which perform photosynthesis with the help of chlorophyll and can make their own food. All plants are members of Plantae kingdom. They are all multicellular organisms which are formed from eukaryotic cells. That is, they have well-defined nuclei in cells and membrane-bound organelles. They contain cell wall which are mainly made up of cellulose. Different functions in their body are performed by tissues. Due to the presence of chlorophyll, most organisms in this class are autotrophic, but some of these organisms are also heterotrophs. Some of these organisms produce offspring from sexual reproduction and some from asexual reproduction. Let us now understand the classification of kingdom Plantae. The first level of classification is based on whether the major body parts of the plant are fully developed or differentiated. Plants whose bodies are without differentiation are placed in the subclass Thallophyta. The next level is made on the basis whether there are specific tissues for the transport of water and other substances in the body of the plants. Plants that do not have specific tissues for conduction in their body are placed in the subclass Bryophyta. Plants that have tissues for conduction are classified based on their ability to hold seed. Seedless plants are placed in the subclass Pteridophyta. Then we classify seed-producing plants on the basis of whether the seed is inside or outside the fruit. Plants whose seeds grow outside of the fruit, that is, if seeds are in open state, then such plants are called gymnosperms. And those plants whose seeds grow inside the fruit, that is, the seeds are in closed state, are called angiosperms. Angiosperms can be classified into monocots and dicots based on the number of cotyledons. Among them, Thallophyta, Bryophyta, and Pteridophyta, the plants in these three groups have very inconspicuous or hidden sex organs and they lack the ability to produce seeds. So, they are called cryptogams. But in gymnosperms and angiosperms, the reproductive organs are fully developed and differentiated. They produce seeds through sexual reproduction. Hence, these groups are called phanerogam. The seeds consist of embryo along with the stored food. When the embryo develops into a new organism, it gets nutrition from the stored food. Let's talk about Thallophyta in detail. Plants like Ulothrix, Alva, Caledophora, Spirogyra, Cara, etc. are included in the class Thallophyta. Their size also varies. Some organisms, such as Climodomonas, are unicellular, which requires a microscope to view them, whereas some organisms, such as kelp, are very large. Differentiation is not found in the body organization of these plants. That is, parts like roots, stem, leaf are not developed in them. All the plants in this group are commonly called algae. These are all aquatic plants. They can do photosynthesis because of presence of chlorophyll and thus can make their own food. That is, they are autotrophic. Some algae are very small and they form layers on the surface of water. These are called phytoplankton. Apart from water, thallophytes are also found in moist stones, soil, and wood. Some of these plants, such as blue-green algae, form permanent interrelationship with certain species of fungi that gives various benefits to both. We call this relationship symbiosis. Thallophytes have various methods of reproduction. In Spirogyra, asexual reproduction occurs by fragmentation. The asexual reproduction in Chlamydomonas results from the origin of various spores called zoospores. In Spirogyra, Cara, etc., sexual reproduction occurs by fertilization of gametes. Now, let's discuss Bryophyta. In this class, liverworts such as Marxia and moss such as Funaria are included. They are often found in moist and shady areas of hills. Bryophytes are also called amphibians of kingdom Plantae because plants of this class live on land, but for sexual reproduction they depend on water. Their body do not have tissues for conduction of water and other substances from one part to other part. They absorb water and nutrients from the surface and the material is carried from cell to cell. Their body is like thallus and is straight. They are attached to substratum by unicellular and multicellular rhizoids. They do not have developed structures like roots, stem, and leaves, but they have similar structures, so their bodies are differentiated than Thallophyta. In these, sexual organs are multicellular. The male sex organ is called antheridium and the female sex organ is called archegonium. From antheridia, male gamete antherozoid is developed, which is released on water. Here, its fertilization occurs with the female gamete egg and the zygote is formed. It is developed into sporophyte. Some of its cells are converted into spores. It develops and produces new organisms. Now, let's understand Pteridophyta. Plants of the type Marsilea, fern, etc. are included in Pteridophyta. This class of plant kingdom consists of all those plants whose body develops completely into roots, stems, and leaves. That means their body is completely differentiated. They have specific tissues for the transport of water and other necessary substances from one part of the body to another. We call such tissues as conducting tissues. Of them, xylem tissue transports water, while phloem tissue transports food and other substances from one part of the plant to another. They neither have flowers nor they bear seeds. The gametophytes have male and female reproductive parts, which are called antheridium and archegonium respectively. Antherozoids are released from the antheridium and reach the mouth of archegonium through water. The egg present in archegonium fuses with the male gamete to produce zygote, which develops into a new individual. So today we learned about kingdom Plantae and subclasses of this kingdom, Thallophyta, Bryophyta, and Pteridophyta. Tissue, meristematic tissue. All living beings are made up of cells. The cell is a fundamental structural life. In different organisms, there are different number of cells. In some organisms, one cell is itself organism. Organisms whose body is made up of single cell are called unicellular organisms. In such organisms, these out all fundamental functions like movement, food intake, gaseous exchange, and excretion. And in other organisms,